left an indelible mark on the world of mathematics. His contributions to number theory, infinite series, and elliptic functions continue to inspire mathematicians worldwide. As we commemorate Ramanujan's brilliance, let us also reflect on the broader significance of Mathematics Day. Mathematics is not just a subject, it is a universal language that transcends time and space. It is the language of patterns, logic, and order that governs the very fabric of our existence. Let this day serve as a reminder of the beauty and power of mathematics, inspiring each of us its depth and apply its principles to solve real world problems. May we draw inspiration from Ramanujan's passion for numbers and his unwavering dedication to the pursuit of knowledge. On this day, let us come together to appreciate the beauty of mathematics, honor the legacy of the great mathematician Ramanujan, and reaffirm our commitment to the pursuit of mathematical excellence. Thank you, and let the celebration of Ramanujan's birth anniversary and National Mathematics Day commence. We are honored to have with us our chief guest, Professor Sushil Kumar Tomar, Vice Chancellor, JC Bose University of Science and Technology, YMCA, Faridabad. It's a privilege to have with us the guest of honor, Professor Om Prakash Yadav, Professor and Chair, Department of Industrial and System Engineering, North Carolina, A&T State University, USA, and Ms. Mani Agarwal, Under Secretary, Development Partnership Administration, Ministry of External Affairs, New Delhi. Thank you and welcome, sir and ma'am. I would all request you to please give a round of applause to our guest of honor. To extend the warm welcome, I would like all the dignitaries to please come up on the stage. I would like to request Professor Sunita Rathan, Director AIAS, to please present the bouquet to our chief guest, Professor Sushil Kumar Tomar. Thank you, ma'am. I would request ma'am to please present the bouquet to our guest of honor, Professor Om Prakash Yadav ji. Thank you, ma'am. I would request Khatri sir to please present the bouquet to our guest of honor, Ms. Mani Agarwal. I would like Dr. Arora to please present a bouquet to Professor S.K. Khatri. Sir, I would also request you to present a bouquet to Professor Sunita Rathan. I would now request Dr. Lovely to please take over from here.
To begin with, I would like to introduce Professor Sunita Rathan, who is Dean Science and Technology, Director, Amity Institute of Applied Sciences, Amity University, Noida. She has a rich experience of more than 25 years in academics and research. She has published more than 75 research papers in reputed international journals and has filed 15 patents, out of which many have been granted. Professor Rathan has supervised many students for their PhD. In addition, she is serving as Secretary, Asian Polymer Association and Society for Biomaterials and Artificial Organs, Delhi. Further, she is a Fellow of Royal Society of Chemistry, London. Now, I would like to request Professor Sunita Ratan ma'am to address the audience.
Distinguished guest of honor, Professor Om Prakash Yadav, Professor and Chair, Department of Industrial and System Engineering, North Carolina and A&T State University. Ms. Mani Agarwal, Under Secretary, Development Partnership Administration, Ministry of External Affairs, and our very esteemed Chief Guest, Professor Sushil Kumar Tomar, Vice Chancellor, J.C. Bose, University of Science and Technology, YMCA at Faridabad, Professor S.K. Khatri, Dean, Research, Innovation and Extension Activities Outcome, and Deputy Director General, Amity Foundation of Science, Technology and Innovation Alliances. Esteemed guests, HOIs, HODs of various departments, our most valued invited guests, delegates, faculty, and students. On behalf of the organizing committee, it's my distinct honor to extend a warm welcome to each one of you to the International Symposium celebrating the contributions of Ramanujan in mathematics in Amity University, Uttar Pradesh, Noida, to celebrate the birthday of great mathematician Srinivasa Ramanujan as National Mathematics Day. Today we gather here on this auspicious occasion to celebrate the birth anniversary of one of the greatest mathematical minds in the history, Srinivasa Ramanujan. It is with great joy and admiration that we mark this day as National Mathematics Day, a tribute to the indelible contributions of a man whose brilliance transcended borders and whose legacy continues to inspire generations of mathematics. Born on December 22, 1887, in the small town of Erode in Tamil Nadu, Ramanujan's journey into the world of mathematics was nothing short of extraordinary. Despite facing numerous challenges and the lack of formal education, he went to make groundbreaking discoveries that can enrich the realm of number theory with modular forms and infinite series. Now, Ramanujan's story is a testament to the power of passion and innate genius. His self-taught journey into the depths of mathematical beauty as he independently discovered theorems and identities that had eluded even the most seasoned mathematician of his time is nothing short of awe-inspiring. Today, we celebrate not just the mathematical prowess of Ramanujan, but also the resilience, determination, and untamed curiosity that fueled his journey. National Mathematics Day serves as a reminder of the importance of fostering a love for mathematics, irrespective of one's background or circumstances. Ramanujan's story teaches us that brilliance knows no barrier. I stand before you today as a self-proclaimed non-mathematician. I am from chemistry department. Yes, you heard it right. I am a non-mathematician. I have done my mathematics only till graduation, and then I shifted back to chemistry. But I'm not here to dazzle you with complex equations and or mind-boggling theorems. Instead, I come to celebrate the marvels of mathematics in a way that might be considered unconventional. I was very good at maths in my childhood and drew inspiration from Jonathan Swift's timeless masterpiece, Gulliver's Travel. I think if you have read that, then Gulliver stumbled upon whimsical land of mathematicians. Here, the landscapes were dotted with giant compasses and protractors, creating geometrical wonders. The inhabitants were wearing the clothes, which were all in geometrical shape. The inhabitants were there were rulers and graph papers everywhere on the grounds. The only discussions they were engaged in about only the elegance of prime numbers and poetry of exhibition. In the land of mathematicians, Gulliver discovered a world where the language of number was spoken with an unparalleled passion. Thus, language also mathematics, turning abstract into a vivid tapestry of intellectual exploration. And that is what is required today in the area of mathematics. Much like Lemuel Gulliver navigating through the strange land of Lilliput, let us embark on the whimsical journey through the vast landscapes of mathematics. In the spirit of Gulliver's travels, perhaps our mathematicians might stumble upon a land where the concept of infinity is not a mere abstract notion, but a tangible, boundless landscape where numbers stretch on forever, much like Gulliver's endless adventures. So we celebrate Mathematics Day today. Let us not only appreciate the profound insight that mathematicians bring to our world, and may our mathematical journey be as captivating as Gulliver's travel. In celebrating Ramanujan's birthday, we are grateful to our Vice Chancellor Ma'am, Dr. Balwinder Shukla, whose unflinching support has always been the driving force behind such endeavors. We would like to express our thoughtful thanks to our founder president, Dr. Ashok K. Chauhan. I would also like to thank our Chancellor, Dr. Atul Chauhan, for giving us the comfortable university and the infrastructure where we can organize these type of events very smoothly. I would like to congratulate Dr. H.P. Arora and the whole mathematics department, which is and Dr. H.P. Arora is backed by a team of very dedicated and motivated colleagues who are performing their duties with full interest and dedication. So let us not only honor the memory of Srinivasa Ramanujan, but also renew our commitment to fostering a love for mathematics and encouraging the young generation sitting at the back, question and dream beyond the confines of the known. May our mathematical endeavors be as boundless and awe-inspiring as the legacy of great Ramanujan himself. Thank
you. Thank you, ma'am, for your inspiring words. It's always been a pleasure to hear from you. To begin the celebration of Mathematics Day, I request all the dignitaries on the dais to light the lamp in worship of Goddess Saraswati.
शारदे माँ अज्ञानता से हमें तार दे माँ मुनियों ने समझी है गुणियों ने जानी वेदों की भाषा पुराणों की वाणी मुनियों ने समझी है गुणियों ने जानी वेदों की भाषा पुराणों की वाणी हम भी तो समझे हम भी तो जाने विद्या का हमको अधिकार दे माँ हे शारदे माँ हे शारदे माँ अज्ञानता से हमें तार दे माँ हे शारदे माँ हे शारदे माँ अज्ञानता से हमें तार दे माँ हमें तार दे माँ हे शारदे माँ हे शारदे माँ अज्ञानता से हमें तार दे माँ.
Now, I would like to introduce Professor H.D. Arora. Dr. H.D. Arora is serving as a professor and head of the Department of Mathematics, Amity Institute of Applied Sciences, Amity University, Noida. A PhD in Information Theory, MPhil in Operation Research, and MBA in Marketing, Dr. Arora is a gold medalist in MSc Operation Research. He has a vast experience of more than 23 years in the education industry. He has published more than 12 books of engineering mathematics, business statistics, numerical analysis, linear programming, and allied areas. He has served publication to his credit in national and international journals of high repute. Dr. Arora has guided more than 7 students for PhD program. He has made valuable contribution to research in fuzzy sets and systems, fuzzy information theory, computational mathematics, and reliability. Now, I would like to request Professor Arora to please address the session.
Thank you, ma'am. Leaders do not dream of success. They get up every morning and make things happen. Honorable Vice Chancellor, ma'am, Professor Balwinder Shukla, ma'am, esteemed Dean, Research, Innovation and Extension Activities Outcome, Professor Sunil Kumar Khatri, sir, respected Director, Amity Institute of Applied Sciences, and Dean, Science and Technology Domain, Professor Sunil ma'am, distinguished Chief Guest, Professor Sushil Kumar Kovan, sir, and respected guest of honor, Professor O.P. Yadav, sir, and Miss Mani Agarwal, ma'am. Head Academics, AIAS, Professor Sangeeta Tiwari ma'am, Head Research AIS, Professor R. Pandey sir, Head of Chemistry, Professor Christine Jesseline, ma'am, HOD Statistics, Professor Neeraj Pawar sir, HOD Physics, Dr. Ashok Kumar sir, delegates sitting off the dais, esteemed colleagues, scholars, and participants. Very good morning to all of you. It is indeed an honor and privilege to stand before you on this occasion of National Mathematics Day. We gather here not only to celebrate the birth anniversary of the renowned mathematician Srinivasa Ramanujan, but also to delve into the depths of mathematical knowledge and explore the frontiers of innovation. Honorable Founder President Sir Dr. Ashok K. Chauhan Sir has always encouraged us to keep growing intellectually and have had a vision to build the nation and the society through providing quality education and nurturing talent in which modernity blends with tradition. We would like to express our sincere thanks to Honorable Vice Chancellor and Chairperson of ISCCR in 2023, Dr. Balwinder Shukla Ma'am, whose visionary leadership has been instrumental in creating an environment that fosters academic excellence and innovation. Your unwavering support for initiatives that promote the advancement of mathematical knowledge has been a driving force for all of us. We extend our heartfelt appreciation to the Dean, Science and Technology Domain, Director of Amity Institute of Applied Sciences, and co-chairperson of ISCC RM 2023, Professor Sunita Rajan Ma'am, who is always a source of inspiration and constant support for all of us. We thank her for leading and inspiring us to conduct this international symposium. We would also like to express our gratitude to the Dean, Research, Innovation and Extension Activities Outcome, and Deputy Director General, Amity Foundation for Science, Technology and Innovation Alliances, Professor Sunil Kumar Khatri sir, for your continuous encouragement and support. Your dedication to nurturing academic excellence has played a pivotal role in shaping the success of various institutions of Amity Universe, and we are grateful for your help. We extend our sincere appreciation to our distinguished chief guest, Professor Sushil Kumar Khatri sir, for accepting the invitation and whose presence here today adds immense value to our symposium. Your achievements and contribution to the field of mathematics have inspired us all, and we are honored to have you here. A special mention of gratitude is also extended to our guest of honor, Professor O.P. Yadav sir. Your expertise and commitment to the advancement of mathematical research have enriched our symposium, and we are privileged to have you as a part of this event. A heartfelt thank you to our guest of honor, Ms. Mani Agrawal, ma'am, for honoring our invitation and joining us at the International Symposium, bringing your unique perspective to the event. We all are eager, ma'am, to hear your challenging and inspiring journey of securing top rank in Civil Service Examination 2017, taking mathematics as your optional subject. The National Mathematics Day is celebrated annually on December 22nd to celebrate the birth anniversary of mathematician Srinivasa Ramanujan. Born in 1887 in Tamil Nadu, Ramanujan had almost no formal training in pure mathematics. Known as one of the greatest Indian mathematicians of all time, Ramanujan worked on theorems that seemed almost impossible to solve. He is known for the work he did in the areas of continuous fraction, Riemann series, elliptical integrals, hypergeometric series, and functional equations of the zeta function. In 2012, former Prime Minister Dr. Manmohan Singh declared December 22nd as National Math Day, and 2012 was only termed and celebrated as National Mathematics Year. While Ramanujan passed away at the age of just 32 years in 1920, it was years later that the government of India decided to celebrate his birth anniversary in the form of National Mathematics Day. By recognizing the contribution of Ramanujan and celebrating National Mathematics Day on his birthday, India acknowledges the importance of mathematics in shaping scientific thoughts and innovation. The aim of celebrating this day is to highlight the achievements of Ramanujan and to stress the idea that having formal and high-end education training is not the only way to achieve greater accomplishment. Like Ramanujan, children are motivated to go beyond the textbook and engage in critical thinking and logical reasoning. The symposium we have gathered for today is a testimony to to our collective commitment to advancing mathematical knowledge. It is a platform for the exchange of ideas, collaboration, and the exploration of new horizons. As mathematicians, educators, and students, we are united by our passion for resolving the mysterious of numbers, patterns, and structures. I would like to express my deepest gratitude to all the participants and delegates who have joined us from different corners of the academic world. Your presence enriches the symposium, and I encourage each one of you to actively engage in the discussion. Share your insights and build networks that extend beyond the confines of the event. I would like to extend a special thanks to our organizers of ISCCRN 2023, Dr. Surbhi Gupta ma'am and Dr. Divya Agarwal ma'am for their tireless effort, invaluable contribution, and the countless hours of dedication in ensuring the smooth flow of the symposium. Let us make the most of this opportunity to celebrate the legacy of Ramanujan and the timeless appeal of mathematics. Together, let us embark on a journey of discovery, learning, and collaboration. I wish everyone a stimulating and enriching experience during this symposium. Thank you.
Thank you, sir, for your encouraging words. Now, I would like to take the opportunity to introduce Professor S.K. Khatri. With more than 24 years of experience, Dr. Khatri is currently working as Dean, Research, Innovation and Extension Activities at Amity University, Noida, and Deputy Director General at Amity Foundation for Science, Technology and Innovation Alliances. Prior to this, as founding director of campus at Amity University, Dakshin, he has established several institutions and departments, before which he had worked as director for Amity Institute of Information Technology and additional director for Amity Directorate of Engineering and Technology at Amity University, Uttar Pradesh, providing leadership for undergraduate, postgraduate, and doctoral academic and research affairs. Dr. Khatri was awarded with Exceptional Leadership and Dedication in Research in the year 2009 and IT Innovation and Excellence Award for contribution in the field of IT and Computer Science Education in 2012. He was conferred with honorary visiting professorship by University of Technology, Sydney, Australia in October 2016, Award of Excellence in Educational Leadership in 2017, INRES Lifetime Achievement Award in 2021, and significant contribution in youth of Uzbekistan in field of ICT by Government of Uzbekistan in 2022. Dr. Khatri is Fellow of IEPE, Senior Life Member of CSI, IEEE, IASCSIT, and Member of IAENG, Secretary of SREQOM, Past Convener EAC, IEEE, UP Selection Executive Council, and past Vice Chairman of CSI Noida Chapter. Dr. Khatri has 14 edited books, 10 guest-edited special issues of international journals, 17 filed patents, 2 international projects, and more than 260 papers in international and national journals, and proceedings to his credit. He has guided 17 PhD theses. Areas of research include artificial intelligence, reliability engineering, and data analytics. Now, I invite on stage Professor S.K. Khatri, sir, to share his thoughts.
Eminent guests on the dais, of the dais, HODs, faculty members, and my dear students. Today is a very important day for the department, for the institution to celebrate, and a very interesting dimension given to it by organizing it at an international level. This first international symposium of contribution by Ramanujan in the field of mathematics. Today is a day not just to celebrate what has been done by Ramanujan, what has been done by mathematicians, what has been done in the past, as such, but to look forward on those foundations and see what we can do as these budding professionals, new students, what you can do to contribute, and that can be the best contribution. And in memory of our eminent, respected, learned scientist Ramanujan, in whose remembrance we are celebrating this day. Today we have with us Professor Sushil Kumar Tomaji as the chief guest for the day, who is a well-known and renowned academician and researcher in the field of mathematics. With his research areas include modeling and numerical methods, convection tools, and continuum mathematics. So your presence today and your sharing of experience that our students will be waiting forward to listen to you is going to be remembered for the time. And definitely it will be a great food for thought for them all to see what they can do from your experience and what you will be sharing with us. We have with us on dais Professor Obi Adalji from North Carolina, Agricultural State University, US, and his research areas include reliability modeling, is mine also, and analysis, risk assessment, design optimization, and robust design and manufacturing and quality system analysis. We also have with us Ms. Mani Agarwal ma'am, who is our guest performer also for the day, and as shared by Dr. Elvi also, that she had topped in UBC exam and she had chosen mathematics as one of the course as an optional paper for the exam. That he talks about the importance that this field has for you and the love this field has for you, and definitely your experience of those days when you have chosen this, but why you have chosen this is something our students will be looking forward to listen to. Dear students, today we will listen a lot of eminent speakers, not only from India, but from US, from Australia. I can see our very dear friend Santosh Kumarji online from Australia, and we have been in connection with each other for almost now more than 2 decades. Since the time of Delhi University when he used to visit to I-Security, which was held by SRE Film Society. And also we have Udaji, nice to see you. And definitely, and I was talking to our learned guests for the day, and some of them are visiting first time. So I said, why this is first time? You should have visited us many times, and it would have been opportunity for our students to listen you and to your experiences. I compliment the organizers, Dr. Hari, wonderful idea and direction you have chosen to take it to the international level. When speakers from such different countries, different fields have been chosen on for presentation today, where they will be telling about their ideas, and definitely our faculty and students would greatly benefit out of it. Recently, just a couple of days back, the institution has organized a great international conference under the leadership of Sri Man, ICRDMD, and which has got a great success with galaxy of people coming from different sectors, different walks of life, and a very vibrant campus was there at that time with all the faculty, all the heads of departments involved into it. And definitely this is the next in the series. It talks about that how actively the institutions and the departments are working in applied sciences. A great congratulations to all of you in the institutions and the departments, and definitely students. It's a very good opportunity to listen to these all learned and eminent speakers who are here today with us. And we all look forward for some great outcome out of it, as the Honorable Founder President says, that this university is an innovation and research driven university, and people like you, your ideas, your experiences, what you are going to share is going to drive us further in this direction. Thank you again for being here, and we are looking for a wonderful interactions and dedication for all of you. Thank you. Thank you.
Thank you, sir, for your encouraging words. Now, I request Dr. Astha to please take over from here. It is our great pleasure to now introduce our guest of honor, Professor Om Prakash Yadav, a professor and chair of Industrial and Systems Engineering Department at North Carolina A&T State University, Greensboro. He also served as professor and duly endowed fellow in the Department of Industrial and Manufacturing Engineering at North Dakota State University, Fargo. He received his PhD degree in industrial training from Wayne State University, MS in Industrial Engineering from National Institute of Industrial Engineering, Mumbai, and DS in Mechanical Engineering from Malviya National Institute of Technology, Jaipur. He has published over 200 research papers in the area of reliability, risk assessment, design optimization, and operations management. His work has been published in various reputed journals, including Journal of Risk and Reliability, International Journal of Production Research, Engineering Management Journal, and IEEE Transaction of Systems, Man and Cybernetics. He served as editor-in-chief and associate editor of International Journal of Reliability and Safety and on the editorial board of several international journals. Dr. Yadav is a recipient of 2015, 2018, 2021, and 2023 IISc William A.J. Golomsky Best Paper Award, 2021 and 2022 SRE Best Paper Award, 2023 Dog Ogden SRE Best Paper Award, 2021 REMS Third Best Paper, and 2023 REMS Best Paper Award. He has received research grants of over $10 million funded by NSF, DOE, NASA, and various companies over a period of last 10 years. He is currently a member of IISc, ASU, SRE, and Inform. Dr. Yadav has also served as the interim chair of IME department at North Dakota State University for 3 years. He is the founding director of the Center for Quality, Reliability, and Sustainability Engineering, which is supported by 10 member companies since 2013. Prior to his tenure at NTSU, Dr. Yadav spent almost 4 years at Ford Motor Company, Dearborn, working as a reliability engineer in Ford Product Development Center and a faculty member at MNIT, Jaipur, India. May I now invite on stage Professor Om Prakash Yadav sir to share his thoughts.
Thank you. Distinguished guests sitting on the dais, our faculty members, colleagues, and students. I'm not a good speaker on these kind of events. You know, if you take me to the classroom, probably I'll be more comfortable in speaking out. But let me take this opportunity to thank Professor Arora being so persistent that finally I had to succumb to his pressure and decide to come over here. Just last night at 2 p.m. we arrived, 2 a.m. right? We arrived here. I'm still sleepy. My daughter is with her. I'm sort of dragging her with me on my commitment, but I'm so honored. I really appreciate for giving me this opportunity, and for the last 15 years, this has been one of my mission. I call it like a giving back to the country or to the society by sharing my experiences, the learning, different pages I have gone through, and then also if I can probably motivate one or two individuals through these interactions, I think it solves some purpose. I can't, none of us can change the whole society or everyone, but please, if we can motivate one or two individuals, it makes a big difference. This is a great opportunity. We are celebrating the birthday of one of the renowned mathematicians, and that brings to me, it's good to celebrate, right? But it's good to remember what our elders or people have done, but at the same time, we should learn and probably follow and maybe do better than what others have done. And the reason I'm bringing it is, I grew up in a small village around 150 kilometers from here. If you travel from Delhi to Jaipur,
My village is almost in the middle of these two big cities. Small village close to town, probably all of you might be knowing is Neemrana. That's where I grew up. I work on a farm. I enjoyed my childhood. I still tell my dean that the life I had in my village during my childhood, if I can get that environment, I will come back here tomorrow. We didn't have electricity. We didn't have water supply. Um, we used to pull water from well every day morning. That used to be a main chore before I go to school. And prepare those, that what you call, chara machines carted every morning. Those are the two main chores I have to do every morning. And then get ready for the school, and then take food for my father who is working on farm before I go to the school, and come back in the afternoon and go to the farm and work. So I've worked almost everything. I've done everything on the farm which you can expect. Every small chore in the village, in the household, even to, bolte mein gaye ka gobar utha ke dane. And I'm telling, I still feel proud of that. What I'm today is because of the education. My father never went to school. My parents never went to school. None of them. I'm the first person who went to school and went to college and probably ran away from here. No, I still feel guilty on that part. But it's education which makes the difference. So what I'm here today, I'm sharing this place with all of you is because of the education. And I really appreciate what MET education system or society, whatever you guys doing, it's a big thing. It's kind of a building this community, building the society, because if there's no education, then the societies are pretty similar to the wildlife, right? We all behave differently and that so on. The education is very, very important, not only here, in every country. If you look at the countries which have developed so far, so-called superpower of competing, only reason is because they are doing better in education. They are doing better in research. And if there is no research, there is no development. So it's very, very important. The reason I'm bringing here is because that's every time when I visit back home and I visit all these universities, I'm kind of more critical rather than talk. And the reason, the intention behind that is to sharing what I've learned here. I'm familiar with the system here. I've learned other system. I'm familiar with that system, and doing kind of stepping back and thinking what's wrong with our system, or how can we be more effective in our education system and be a better country, be a more developed country, and so on. My observation is that our education system is not what it used to be when I was a student. I don't know the reason, but I think the quality of the education has gone down. And I'm saying here, I'm sharing the experience. Before me, any Indian student applying to the US universities, the professors will jump on student from India must be very good in mathematics, because that's what we are looking for. And the reason I'm saying is, in US, professors get 9 months salary. We are paid 9 months. If we need more salary than 9 months, we have to bring it. We have to write the grants. If I want my summer salary, I have to write the grant and I have to bring my own summer salary. Universities don't pay the summer salary. So if I don't do anything, if I don't do any research, if I don't get any grant, I don't get 3 months summer salary. Number one. Number two, all of the students who are going there for master's and PhD program, universities don't pay them. If I want to have a PhD student, I have to bring the money from my. So if I hire one graduate student, I need to have at least $50,000 for that student to support, with the stipend, taking care of the tuition fee and all other expenses. So if I have to spend, if I need, let's say, two PhD students every year, I need to have at least $100,000. If I don't have, I cannot have the PhD students with me. So now imagine to bring those $100,000 a year, I have to work day and night. I have to write a proposal. And in National Science Foundation, the funding success rate is 7 to 8%. That's the success rate. If 100 people are applying for a grant, only 7 or 8 of them will get funded. So we get rejected. And sometimes you'll see the comments, the reviewers write like, oh, the guy has no idea what he or she is writing, So those kind of comments you get and you don't give up. You have to keep working so that you can get money, take care of your summer salaries, bring more students. And the reason I'm bringing, because if I have to spend $100,000, I'll be looking for a student who is committed, who is willing to work hard. And honestly, nowadays, majority of the graduate students, not me, but other universities, and I go to the conferences almost 3-4 times a year. I meet with the other faculty members and ask them, you guys don't have Indian graduate students, what's going on? And one of the famous professor, Dr. David Coy at Rutgers University, him and I have been, and you might be knowing, he's an expert in reliability engineering. We've been attending conferences for the last 20 years together, and 2 years back I asked David, in the last 20 years, I haven't seen a single Indian student. What's wrong with that? He will have Chinese, Mexican or Iranian students, and he calls me OP, tell you the truth here. I don't hire Indian students. And I said, why? And he said, even if they are from IITs. I said, why? And he said, there's a couple of reasons. Number one is they have the attitude problem. And I don't know where, and I think I agree with him to some extent. They have the attitude problem, especially from IITs. They don't want to work hard. They don't want to do research. They just want to come here, finish the coursework, take the degree, start earning money. And there's nothing wrong in that. I mean, all of us do that. But why would I hire someone, spend $50,000 a year, and person doesn't even do anything? The reason I'm bringing, and I'm not criticizing. I'm kind of throwing the idea, and because I worked at Ford Motor Company, and at Ford Motor Company, as a design engineer or as a reliability engineer, we always look at it, what went wrong? Because if I don't understand what went wrong, I cannot improve the design. So if I want to improve any system, first thing I need to know what's wrong with the system. What are the weaknesses in the system? What are the failure modes? And then how can I either eliminate that failure mode or at least delay the initiation, the occurrence of that failure. And that's how we improve the system. So the reason I'm bringing here is, all of you guys are in a position to make some difference, and especially new generation and new bureaucrats, Ms. Agarwal, and people like her who are in a position to at least make some impact, some changes, because US is a very smart country. Smart in the sense, there's all this politics and everything. But why on the earth they allow every individual, irrespective of which country, religion, or race he or she belongs to, they'll talk bad about China, they'll talk bad about Iran, they'll talk bad about everyone. But if you're a smart person, even if you're Iran, they will give you the visa. They will give you the green card, they'll give you the citizenship, and you want to stay over there, because that's how they are basically. It's kind of churning, pura cream nikal karke upar jaise, the image of that, take it away. because that's how you grow. That's how you make the progress. So we have all those constraints, compulsions, but can we do this churning and identify and promote those individuals who are not necessarily in education? We have a different level of different types of expertise and capabilities. That's the only way we can grow or we can develop, make the progress. Another challenge which we are facing these days is, when I graduated, whatever I studied in mechanical engineering, for 10, 20 years, I taught the same material. The pace of change was very, very, very slow. Today, the pace of change is very fast. What we do today after 2 years, it becomes almost obsolete. Technology is evolving, changing. I mean, believe me, the kind of research I'm doing now, never studied that. There was no programming, right? There was no computer even. It just came in at that time. So all kinds of research that I'm doing now, I never studied that. But if I want to be relevant, if I want my 3-month summer salary, if I want PhD students to work with me, I have to learn. I have to evolve myself. I have to build those capabilities so that I can be relevant within the group or within my department or within the educational system. In US system, it doesn't matter how great you might be brilliant, but if you're not interacting with the outside world, nobody cares here. Because over there, we call it the networking relationship. In academia, you have to have your relations. You have to have that network going on so that people know you. When you submit the paper, oh yeah, we know who this guy is. When you go to the conferences, when you write the proposal, yeah, we know who this guy is, because your name makes a huge difference. So it's very important that we build that relationship, we do the networking, we commit it. And Professor was talking about before his retirement, I was listening very carefully. He published 40 papers. And after retirement, he published 100 more papers. Why? Because he has he has given up all those responsibilities, the fears of losing job or fears of it, totally committed. It became his hobby. Now, if you don't do the research, if you don't keep interacting, you become bored, right? Like there's nothing in the life to do it. So it's very important. And the Indians, I feel, the Indians had, and especially those who went to, we have this problem. We never had any hobby. All we did is, chalo ya to khet pe kaam karo ya padhai karo. From the two things, and there's no hobby developed, and that's the biggest problem even I face. My kids make fun of me that you don't know anything. It's very important to develop. So even as sir, you're saying, this is a hobby. You're writing papers, you're motivating the new generation of academicians and researchers. It's a very, very, I really appreciate and I thank you for doing that, because every year you motivate at least one or two new individuals. Makes a huge difference. And if all of us can do that, and that's my mission. When I come here, I could have easily I'm just arriving, I want to go sleep or meet my family, and I want to go there because I want to avail these opportunities, share my experiences, build that network and relationship. It gives me some level of satisfaction, and I'll keep continuing that. But I appreciate. Thank you very much for inviting me, and all the best for the rest of the day. Thank you.
Thank you, sir, for your kind words. Now, it is our great pleasure to introduce our guest of honor, Ms. Mani Agarwal. Ms. Mani Agarwal did her BSc Honours in Mathematics from Hindu College, University of Delhi, and MSc in Mathematics from IIT Bombay. She cleared UPSC exam with All India rank of 126 in 2017. During 2017-2018, she was an officer trainee at Lal Bahadur Shastri National Academy of Administration, Mussoorie, and Sushma Swaraj Institute of Foreign Service, Delhi. From September 2018 to February 2020, she was posted as third secretary in Embassy of India in Paris and learned French language from Institut Catholique de Paris. She worked as a second secretary in Embassy of India in Madagascar during March 2020 to March 2023. Presently, she is posted as Under Secretary, Ministry of External Affairs in New Delhi. May I now invite on stage Ms. Mani Agarwal to share her thoughts.
Respected Chief Guest, Guest of Honor, members of the organizing committee of the International Symposium, distinguished speakers, and dear students and the staff of MIT University, wishing you all a very good morning. And, I would like to start with a thought that we are celebrating today the birth anniversary of Srinivasa Ramanujan, who is one of the most prolific mathematicians and a great inspiration for all of the students who study mathematics around the world. And I would like to extend my heartfelt gratitude to MIT University and in particular MIT Institute of Applied Sciences for inviting me to this event and convey my best wishes to all those who are participating in the International Symposium. I have moved back to Delhi in March this year itself, and this is my first outside interaction with people, specifically universities, and I always enjoy being a part of such events. Mathematics has a rich history in Indian subcontinent as a whole, with many Indian mathematicians contributing in one way or the other to the growth of mathematics as a subject. Srinivasa Ramanujan, many people have already spoken about him, but his contributions are not just related to mathematics, but also as a person, the kind of person he was. He was from a very humble background with no formal education, but still very consistent and confident in his thoughts, which also reflected an exceptional intuitive grasp of mathematics as a subject. Since a very young age, and also he unfortunately died very early. Although it has been more than a century, today also we continue to get inspired from Ramanujan, and we believe that he's not just a simple symbol of exceptional mathematics, but also the strengths of human mind. Today, whatever I have managed to achieve in my life, I have also heard from the introduction which she gave. I owe it to a large extent to mathematics, and I have been very much interested in mathematics since in my school days. It continues to be one of my favorite subjects. But one interesting part is 80% of the people I meet, they are afraid of mathematics. So it includes my friends and my family members also, and they always used to, positively taunt me that you are mathematicians and you will always, grill people all through your life, etc. But I think my love for mathematics is one thing, but I was also blessed with some of the very good teachers who supported my love in that manner and also taught me in a way which inbuilt confidence in me to take, as she mentioned, that in one of the most competitive exams of India. So it never occurred, I was never doubtful of the fact that mathematics was going to be my optional subject. Although I had failed in one attempt of UPSC, but second attempt also it never happened that I would change my optional. So even my parents suggested that I might change my optional because it was because of mathematics in a way that I couldn't score a rank. But I was very convinced that only mathematics will give me a good rank because I was very strong in that subject, and with around 15 years of experience in being around, and studying mathematics in a greater detail. So I never left it. And I think that today mathematics It has been there for a long time, immemorial time. But importance of mathematics today has never been felt as before. Specifically with the advancement of technology and everyday lives, mathematics has become an integral part of it. And it's not just related to basic calculations, which we used to do, but also the things which encompass our daily lives, including digital transactions, and also how our lives revolve, our education, our companies, our trade with different countries. Everywhere it's mathematics, everywhere there is market. So today with increased importance of mathematics, I think that there are numerous opportunities for students as well. It's not just related to pursuing mathematics just as a stair to reach wherever they want. Of course, it's one, but also it offers many opportunities in what they can become by using mathematics as a subject. They can become teachers, they can become, of course, researchers, but also they can jump into different fields. And mathematics and information or maybe interest in mathematics will help you get there, be it commerce, be it sciences, be it technology or management. And it is here that institutions like MIT University and others play a crucial role in offering the necessary platforms to explore the world of mathematics in different ways. I would like to appreciate the work done by this university to provide that platform to students and also an atmosphere which generate critical thinking. And I think the symposium which we are celebrating or organizing today is one such example. Today we have gathered here not just to celebrate the birth anniversary, but also the idea of Srinivasa Ramanujan, who reflected the genuine love for the subject and also taught us how to achieve our goals or maybe being consistent in our efforts in spite of the challenges that come. Because it's not easy for anyone. We all struggle and then we achieve things. And the struggles that Ramanujan faced are like uncomparable as to what we are. I think that lives have become really more comfortable today than to what life Ramanujan lived. And with those challenges, he has achieved so much. We can, I think we can get some inspiration and maybe achieve some percentage of what he has achieved. So I would like to say that let's embrace the beauty of mathematics and the idea of Ramanujan today. Thank you, everyone.
Thank you, ma'am, for your kind words. Now, with great honor, I would like to introduce our chief guest, Professor Sushil Kumar Tomar. Professor Sushil Kumar Tomar is a distinguished academician, researcher, and educational administrator. He is currently the Vice Chancellor of J.C. Bose University of Science and Technology, YMCA, Faridabad. Professor Tomar, who is also a well-known mathematician, assumed the office of Vice Chancellor on February 22, 2022, as the seventh Vice Chancellor of the university. Prior to joining J.C. Bose University, Professor Tomar was Dean of University Instruction at Punjab University, Chandigarh. The career of Professor Tomar as an academician and researcher spans over 34 years. He brings with him a rich mixture of professional expertise and administrative experience. He completed his MSc, MPhil, and PhD degrees from Kurukshetra University. He engaged in various activities in Guru Jambheshwar University, Hisar, in its formative years during 1995 to 1999 and established the Department of Applied Mathematics in the university. Professor Tomar joined Punjab University in 2000. He was the chairperson of Center for Advanced Study in Mathematics from 2012 to 2015. He remained as Honorary Director of UGC HRDC at Punjab University, Chandigarh from 2019 to 2022. He has served in various positions in Punjab University, including Dean Instruction, Dean Student Welfare, and Dean Research. Professor Tomar is known for his research work. He has 128 publications in the journals of international repute and has delivered over 150 lectures in the country and abroad on the different topics of this research. He is elected Vice President of All India Association of Vice Chancellors and Academicians, New Delhi, for the period 2020 to 2025. Professor Tomar has also been honored with the prestigious IAPS Fellowship Award for his exceptional contributions to the field of mathematics by the International Academy of Physical Sciences, Prayagraj, during the 29th International Conference of the International Academy of Physical Sciences, held from July 21st to 23rd, 2023 in Dehradun, Uttarakhand. In order to sensitize science education among the children and to all other corners of the society, he initiated Chandigarh Vigyan Parishad in the year 2016, which is a part of Vigyan Bharati at national level. He is also an elected fellow of National Academy of Science, India, and is the recipient of P.L. Bhatnagar Award Lecture of Indian Mathematical Society. On this note, I would like to invite Honorable Chief Guest Professor Sushil Kumar Tomar sir to motivate the audience.
Good morning, everyone. And I would request that please switch off or put your mobile on silent mode because everybody is busy with this mobile. And I know the importance of the mobile. And whatever we are surviving today is just because of Srinivasa Ramanujan, because he did work in number theory. And the numbers are the lifeline of our life. Everyone is taking. Anyway, Professor Balvinder Shuklaji, who is not present, the reason is unknown to me, the Honorable Vice Chancellor of MIT University, Professor Om Prakash Yadav ji, guest of honor from Department of Industrial and System Engineering, North Carolina, A&T State University, USA, Miss Mani Agrawal, guest of honor, Under Secretary, Department of Partnership Administration, Ministry of External Affairs, New Delhi, Professor S.K. Khatri ji, Dean, Research, Innovation and Extension Activities, Outcomes, and Deputy Director General, MIT Foundation of Science and Technology, MIT University, Professor Sunita Ratanji, Dean, Science and Technology Domain and Director, MIT Institute of Applied Sciences, MIT University, and Professor H.D. Arora, Head of the Department of Mathematics at MIT Institute of Applied Sciences, MIT University. And our Vishnu Vitaman, who is present here, Professor D.S. Hooda, though he's sitting on the other side of the dais, but he is making his presence effectively here. And some speakers have already spoken about him. And there's no doubt he is one of the luminary, or you can say, the motivating force for all of us. Dr. Divya Agarwal and Dr. Shurbi Gupta, who is the organizers of this National Mathematics Day. Invited speakers, guests, worthy faculty members, participants, dear students and media persons available here. Today, we gather here to celebrate National Mathematics Day. Earlier speakers have spoken about the legendary mathematician, and there may be some reiteration. I apologize for that. But that reiteration is important. I would like to connect the things to the present scenario. And it was given a question to me by Professor S.K. Khatri, that just connect or tell us to our students how mathematics can be learned and how we can contribute significantly for the development of the human mankind. The Development of the country is another thing, is in terms of the growth and progress. But how the scientific community can be benefited by the development of mathematics. That is much more important here. See, as you are aware that we are here to commemorate the birth anniversary of Srinivasa Ramanujan, a legendary Indian mathematician who was born on 20 December 22nd, 1887 to a Tamil Brahmin family. The former Prime Minister of India, Dr. Manmohan Singh, paid tribute to Srinivasa Ramanujan in a function organized on the occasion of the birth anniversary of Srinivasa Ramanujan in 2012. And everybody knows that since then we are celebrating National Mathematics Day. And I think it is 12th National Mathematics Day we are celebrating in the country. Srinivasa Ramanujan's life and works exemplify the transformative power of mathematics despite facing numerous challenges like economic problem and health issues. These were the two major problems he faced in his life. Ramanujan's work encompassed profound discoveries in number theory, in finite series, modular forms, etc. So actually, we have been told many of times by our teachers or by other people from scientific community that Ramanujan was a great mathematician. No doubt, this is because of the work the people recognized. Now, the question comes, as Professor Yadav also pointed out, how can we go ahead to develop mathematics in our country? He also posed certain problems, narrated some of the incidences, what is going on in present days, that why the US supervisors are not accepting easily the Indian students. And he is very right. I also admitted that somewhere there is a problem. But actually, we have a habit to point out from our side, and we don't have a habit to point out ourselves. Don't you think that there is some problem with the teachers who are not able to inculcate the interest of mathematics among the students? Do you feel that scoring good marks is just the learning of mathematics? If you score good marks, I feel that you are just problem solver, not more than that. But actually, have you adopted mathematics in our life? See, we complete the question, we solve the question, the evaluator gives us full marks, and we become happy. And the society declares us, you are a great mathematician. Was it the case with Ramanujan? He did not pass class 2 examination even. This is not the case with Ramanujan. Then what else we require? What else we should do? It's not the money problem. It's not any problem of the policy from the government side. It's actually the problem with we people, we teachers. And do you think that the giving more salary would enhance the standard of education? Giving more funds to the educational institutions will enhance the standard of education? Not at all. See, what can we do in a system? We can force the teacher, come on time, go to the classroom. Even the administration can catch the teacher and can lead to the door of the classroom. But inside the classroom, who is responsible? It is the teacher. And if you don't have that kind of passion, it is not going to be possible what we are talking today. So we must ponder upon. And the same thing is being done while we recruit teachers. Is there any question how much The candidate is passionate about teaching. How much capability and ability the candidate is having to inculcate the interest about a particular subject? Nothing. Only a rectangular piece of paper, what we call the mark sheet, is being seen, and on the basis of some API performer, we select the candidate and we declare that we have hired the teacher. Actually, the problem is that India facing today is the which I should, most difficult problem in education and teaching is to hire good teachers. Look at our teachers, like in the era of 1960s or before that. How much passionate teachers were. And they were hardly getting the sufficient salary. They were always look forward the evaluation of question papers, some other duties for just survival. Because his or her child has asked that I want to buy a bicycle, and for that. But the passion, they used to stay even at night in the schools. But nowadays, the things are different. Only a mechanical system is there. Teacher is coming to the classroom, going to blackboard, just worried about how to complete the syllabus, and then going back. No interaction with the students. And with this, what had happened? Students have left to ask the question. And there is no question in the classroom, isn't it? Am I telling you the truth? And if there is no questioning, how can you expect that the mathematics will grow? Basically, the purpose of mathematics is to open the mind more than solving the question. That is the most important task of the teacher. While solving the question, proving the theorem or lemmas or proposition, don't you feel that the interpretation of the same result is much more important? Otherwise, the people who are from non-mathematical background, what they say? They are in alpha, beta, gamma, and not more than that. See, the numbers 1, 2, 3, 4, 5 don't have any physical appearance. But even the whole world is surviving because of the numbers. The communication is nothing but is the transformation of your digits, which is in the form of bits and signals. We call it as a signal. You go to the health issues problem. All the numbers are being displayed. Sugar level is this, blood glucose is this, and whatever. See, you see, without numbers you cannot survive. And today you see that Aadhaar card number, your passbook number, your what you call the passport number, bank transaction, what not. Without that, the people who are not very tech savvy, they face a problem that we don't want to go into because it is very difficult to go into that at this stage. So this is where the problem is. Once you stop learning, that means you have become old. And if you continue your learning, you will never become old. And many people just have a fear of this computing or the system they have developed. Just think that how the system has been simplified. Go to your airport, you know each other. How it has been possible? Because of the blockchain technology, because of the artificial intelligence, because of the machine learning. And those who are working in AI and ML, they know very much that the importance of mathematics is very much there. Because the graph theory and the discrete mathematics, that is the crux of all these subjects, the heart of all these subjects. I'm not, though I told you that I may repeat something, but anyway, I'll let you know why the repetition has been taken. I'll know how much I have to just tell me, because the time is more important than the people are. 2 more minutes. Anyway. Okay, okay. Students, how many of you are aware that minus into minus is plus and plus into plus is plus? You know, there is a proof, and the proof came from very beautiful equation of mathematics, which was given by Euler, and is e raised to power iota pi plus 1 is equal to 0. There may be number of proofs in mathematics. So one thing which I would like to convey you, after solving the question, take a pause of few seconds and think, can I do it differently? Or can I apply the same strategy in other fields, maybe belonging to engineering, physics, or chemistry? Because it is a fact that without mathematics, no scientific discovery is acceptable. The scientific discovery is acceptable only if it has passed the mathematical test. Today, any scientific research or social science research, you look at any paper, it covers the part of some analysis, and then only it is published. So mathematics is always there. It is not just the mathematical calculations or few calculations which you call arithmetic. So many times you understand that if there are some calculations, it is mathematics. No, it is just arithmetic. So just come out of the box and try to think why it is so. Why e raised to power iota pi plus 1 is equal to 0 is a beautiful equation. What's beauty in it? See, this equation basically has 5 constants. One is E, given by Euler. Other is I, imaginary number. Next is pi. Other constant, you know the meaning of pi. Next is 1 and 0. 0 is the only number which cannot be divided by itself. 1 is the only number which is divided by 1 and it is neither prime and nor composite. Pi, you know. I, you understand. E, you also understand. Now, let me come to the importance of what we are doing and is very important, which is called the approximation or the applied method. See, can you find out the exact value of 1 by 9 or 1 by 3? No. But even then the whole world is going on. Do you know the exact value of pi? Not at all. But even then the whole world is going on. So can you survive your life without approximation? Approximation is always everywhere. So those who are saying that the mathematics is an exact science is not true. It is again an approximate science. In 2016, there is an article from a professor of Tejpur University in the Journal of Current Science, published from Indian Academy of Science, Bangalore. And what he says, science is never exact. So these things actually motivate you how we should go ahead. Let me come to see, P.R. Halmos was very great mathematician. He used to say, in any of the mathematical meeting, we should talk about some theorems, lemmas, propositions, or some problems. So let me talk about few theorems. Rolle's theorem is one of the important theorem. Everybody is aware of it. So every student is well remember this theorem. But do you know that this theorem is nothing but evolution of our day-to-day practice? Suppose I am going from Delhi to Chandigarh, maybe via aeroplane or maybe by taxi. So this whole phenomena justify the truth of Rolle's theorem. See, the three conditions are there. The function should be continued, continuous function over the closed interval a to b. It should be differentiable over the open interval, maybe on closed interval, doesn't matter. And third thing is that f of a is equal to f of b. Then there exists at least one point c where the derivative of the function is equal to 0. So this is everybody remembers, but actually what is happening in practical life that you went from Delhi to Chandigarh via your car or the aeroplane. It's a continuous function. There is a speedometer inside the car. There is a speedometer inside the aeroplane. You can check the speed. It's differentiable. F of a is equal to f of b. Aeroplane was grounded here. Aeroplane was grounded there. And therefore, if anybody asks you at Chandigarh, what was the speed of your car or what was the speed of your aeroplane? So certainly you will tell like 60 km per hour, or the aeroplane would be like 200 km per hour. But was it actually there? No, not at all. You might have had your breakfast within the way. You might have slowed down because of the traffic congestion and so on. But actually there was at least one point where the speed of your car was exactly what you are telling. So this way of actually teaching to the students is much more effective than just telling them. And that's why the problem is the students of mathematics, they cram the theorems and the statements very well, but even they are not clear what is the correct definition of function. Similarly, let me go little bit up. There is a very important theorem in metric space, which you call center intersection theorem, which says that let X3 be a complete metric space and Fn be a sequence of closed subsets of X, such that F1 contains F2, F2 contains F3, and so on. Then there exists or intersection of all Fn's contains exactly one point or non-empty. Isn't it? And you know what is complete metric space and other things. This is because we all have been taught by our respected teachers. But don't you think on the other side, this bisection method is nothing but the exact creation of what you call the Cantor intersection theorem. So you need to relate these things. How it is true? Because your real line is your complete metric space. Complete metric space is that space where every Cauchy sequence has a converging point inside that. And it is true. You can frame, you can construct a Cauchy sequence of real numbers and you can see that it belongs to the real line. Okay. And then the bisection method says that you pick up 2 points, A and B, where the roots are enclosing. That means f of A into f of B is less than, and based upon Weierstrass theorem, and you know very well. And then you can be called this first enclosing root set. Is a closed set is F1. Then you bisect it. Certainly, the bisected interval F2 would be contained in F1, and so on. You go on, and that's why you pick up the exact root, or you come close and close to the exact root of the polynomial equation with real coefficient, provided that the polynomial equation must have the real roots. So there are so many things, but the time constraints are there, and therefore I want to stop here. Thank you very much for inviting me, listening me patiently, and I wish all the best for the success of the conference. Thank you. Thank you.
Thank you so much, sir, for your inspiring and motivational words. Now, I would also like to welcome and say thanks to Professor Santosh Kumar, sir, from RMIT University, Melbourne, Australia, who has taken out time from his busy schedule to join us online. Thank you so much, sir. Now, I would like to request the dignitaries on the dais to please come forward and inaugurate the abstract book of the symposium.
How do I
Santosh sir wants to say something, please, sir.
Yeah, how do I share the screen? Do I start or
We can hear you, sir.
okay?
Okay, how to share?
Yeah, can you see? Can you see the screen?
Sir, please wait for 2 minutes.
Okay.
May I now request Dr. Riju ma'am to take it from here? Thank you.
Santosh sir, your session will be later. In case you wish to speak something right now, you please may. Your session is later.
Oh, his session is later. Okay, okay, okay. Well, I thought my session starts. You see, so it is not the time for that. Okay,
This is the
okay,
inauguration ceremony, yeah.
yeah.
After this, I will sir just let you know the time. It is a little later.
Okay, okay. No, then I'm just attending. That's thank you.
Okay, sir. Thank you so much.
Yeah.
I would now request Professor Sunil. It's okay, then just waiting for ma'am to come. I would now request Professor Sunita Ratan ma'am to present a memento to our chief guest, Professor Dr. Sushil Kumar Tomar.
How do I stop this very sharing?
Thank you, ma'am. I would request ma'am to also felicitate Professor Om Prakash Yadav, our guest of honor, with a memento. Thank you, ma'am. I would request Professor H.D. Arora to present a memento to Ms. Mani Agarwal, our guest of honor. Thank you, sir. Sir, I would request you to please felicitate Professor S.K. Khatri with a memento too. Thank you, sir. I feel honored and privileged to now propose a vote of thanks on this symposium on National Mathematics Day organized by AIAS. Firstly, I wish to convey my deepest appreciation to our visionary founder president, Dr. Ashok K. Chauhan, for establishing this esteemed institution and for giving us a platform to organize this symposium in our campus. I extend my heartfelt thanks to our esteemed Vice Chancellor, ma'am, Professor Balvinder Shukla, for her constant support, motivation, and blessings. My sincere thanks to our head of institute, Professor Sunita Ratan ma'am, for her unwavering support, constant help, and guidance that radiates a source of energy within us. I would like to thank her from the bottom of my heart. All guests, speakers, dignitaries for taking time out from their busy schedule to share their experience and expertise with us and our students and to motivate all of us. I would like to thank Professor Sangeeta Tiwari ma'am, Head Academic Coordination, AIAS, Professor R.S. Pandey, Head Research, for their help and support at various stages. I also acknowledge and express deep gratitude to the Head of Department Mathematics, Professor H.D. Arora. His dedication and leadership in the mathematics department has been instrumental in fostering academic excellence and nurturing the next generation of scholars and innovators. We deeply appreciate his support and commitment to creating and enriching educational environment. I would like to thank the head of departments, Dr. Christine from chemistry, Dr. Ashok from physics, Dr. Dheeraj from statistics, for support in all possible manner to organize this symposium. In busy schedule, they find time for motivating and igniting the young minds always. I'm also thankful to our current and former faculty colleagues, non-teaching staff members, IT technical team members who always stand by us and help us at every step. Coming to the end, my dear students, you're all fortunate enough to be baked by a team of very motivated and dedicated teachers and researchers. With these words, I would like to end this inaugural session, but our journey of excellence starts from here. Thank you and have a good luck. I request you all to please proceed for high tea. Dignitaries and faculty members are requested to proceed to the adjoining room F2 lounge, and the students are requested to proceed to the F2 foyer. Shweta ma'am and the team of volunteers will guide you all. Thank you.
यार मैं जूम से अपने स्क्रीन पे कैसे जाऊं अपनी फाइल को खोलने के लिए इस टाइम जो है it is he's writing you are sharing the viewing F2 seminar screen so नहीं मैंने नहीं शेयर किया उन्होंने किया होगा ना उन्होंने स्टॉप कर दिया अब मैं वैसे व्यू पे आ गया हूँ
सर आप एक काम कीजिए अपनी प्रेजेंटेशन ओपन कीजिए मैं बताता हूँ
हाँ तो कैसे करूँ उसको मिनिमाइज कैसे करूँ कहीं
आपने प्रेजेंटेशन ओपन करी हुई है अपनी
हाँ
हेलो
या एक मिनट सर एक मिनट सर I can see this screen and I don't know how to go back to my screen of
sir have you opened your presentation
yes I opened it but I closed it also something I was not able to control how do I go back to my screen at the moment I am on I can see the hall I can see myself and seminar hall and MT University F2
you are on the Zoom tab.
Yeah, I'm on Zoom.
So
how to minimize this?
In the bottom, you are able to see the share screen button.
Yes, I can.
Click on that green button.
Okay, I did.
Now you will see the first option, screen.
Basic screen. So my file is, I can see, if I click it,
you can double
it
click.
Is open.
Yes, you have to click on that. Double click.
Okay, yes. Now that has come on my screen. Yeah.
Yes. Now you can go to the that slideshow mode.
a slideshow mode, that is okay. Yeah, just a minute. I saw it yesterday somewhere.
In the bottom also there is
a cup like thing. There's a cup like thing. In the bottom, are you seeing my screen? No.
Yes, sir. I'm able to see your screen. You can go to the slideshow mode. You also find the slideshow option on the top near the animation. File, home, insert, draw.
Design, add animation, shape. This is.
Or you can click F5.
F5. No, I saw it yesterday, but at the moment I can't. I saw how to increase this also. That is full screen.
Sir, are you able to see the at the top? You see the option home.
Here on record designer. I think they are
Slightly left. Yes, near the help view. Take the cursor. Yes, yes, sir.
help. Yes.
Now view,
Yes.
record, slideshow.
Record slideshow. Yeah. Okay.
Now click on from the beginning. Right.
Right.
Got it.
Okay. Yeah.
Now you can change.
I can change by. Okay. No sound.
And multi-criteria decision-making as a tool for interdisciplinary research in human resource development, marketing of brands, big data projects adoption, and other areas of management is phenomenally illustrated through his work with over 42 PhD and 25 MPhil scholars. He is an author of two books titled Software Reliability Assessment with OR Applications, Springer UK 2011, and Contributions to Hardware and Software Reliability 1999. World Scientific, Singapore, and editor-in-chief of International Journal of Systems Assurance Engineering and Management published by Springer. He is the series editor of book series Asset Analytics, Performance and Safety Management, published by Springer. He has executed various research projects from UGC, DRDO in the areas of software reliability and innovation diffusion modeling. He has been the president of Society for Reliability Engineering Quality and Operations Management since 2000 and former president of Operational Research Society of India. He has edited 7 volumes of conference proceedings and special issues of various international journals. He has over 350 research papers, publications in top international and national journals, proceedings of repute. He has delivered several keynote addresses, invited links in various prestigious international and national conferences, and has been invited to deliver lectures in the international universities in Sweden, Denmark, South Africa, Serbia, etc. He has been recently awarded with the Best Teacher in Operations Management by Bloomberg and UTV and Lifetime Achievement Award for Global Leadership and Pioneering contributions to the field of software reliability engineering, along with an award for his dedicated contribution to the development DQM Research Center, Serbia, June 2014.
I request Professor P.K. Kapoor, sir, to please come up on the dais.
Santosh sir, are we audible to you now?
Yes, I can hear you. Yeah.
With over 24 years of experience, Professor Khatri currently holds.
We can skip it, please. Let us start the session.
So without further ado, let's welcome Professor Sunil Khatri sir and P.K. Kapoor sir to start the session.
So welcome to the first technical session of this international symposium. And I invite Professor O.P. Yadav on the dais. I also invite Professor Huda to please join on the stage. You are more comfortable here? Do we have Professor Mohammad Tansir also? Yeah. Okay, he is online. So I will introduce our first speaker for the session, Professor O.P. Yadav. And he is Professor and Chair of Industrial and Systems Engineering Department at North Carolina A&T State University, Greensboro. He also served as Professor and Endowed Fellow in the Department of Industrial and Manufacturing Engineering at North Dakota State University, Fargo. He received his PhD degree in Industrial Engineering from Wayne State University, MS in Industrial Engineering from North National Institute of Industrial Engineering, Mumbai, now known as IIM Mumbai, and BS in Mechanical Engineering from Malvi National Institute of Technology, Jaipur, India. He has published over 200 research papers in the area of reliability, risk assessment, design optimization, and operations management. So, over to you. And we will request the speakers to have their speech for 20 to 25 minutes so that we can have 5 minutes for interaction also. Thank you.
Thank you. I just want to make clear, my background is not mathematics. I'm an engineer, but I use the mathematics, and that's what my whole presentation is when we create a system or when we design a system, what is the role of mathematics in that? You know, how the mathematics plays really a significant role to design and create a reliable system or reliable product. And I picked up a very simple example that we worked on several years back, a suspension system. You know, your motorbike which you drive or the car you drive has a suspension system. That's where you have the comfortable ride when you're riding the motorbike or car and going in the uneven road conditions, and you don't feel that bump, you know. So in that process, there are several issues that we try to address to make sure your product is reliable and it meets all of those requirements. So in today's environment, given that the expectations of the customers are increasing, you know, you expect highly reliable product, meeting all of your requirements, whatever things you want to do with that product, and then you want it to survive for whatever the product design life is, whether it's 2 years or 5 years or 10 years and so on, and then you are using it. That's another challenge which most of the design engineers face is each one of you in this in room or each one of us have the different requirements, have the different expectations, have the different habits of using or misusing or abusing the product. And as a design engineer, I need to capture all of those good and bad habits while developing the mathematical model and designing the product and so on. And then, of course, the other factors which are constantly introducing the variability in your system or the product and so on. So, and then you have conflicting technical or the customer or the product characteristics. You know, if you try to improve upon one, the other gets impacted negatively. If you try to improve upon second one, the third one gets impacted. How do we optimize? So in my presentation, the talk that put together is I'm really using the optimization techniques. I'm using the statistical models. I'm using the differential equation, the calculus. I'm using the economics to minimize the total cost or the objective function and so on. So everything, all of these researchers from different domains, you know, mathematics, statistics, operations research, ideas and concepts they develop, we bring all of them together to design the more reliable systems and products and so on. So it's really the engineering design presentation, but I'm trying to emphasize that how important mathematics is, because everything in life is really the foundation is mathematics. Even in the physical system, the space I'm standing on is based on the mathematics. You know, everything they're using are based on the mathematics and so on. So when, as I said, we capture the randomness or the variability in the system or the universe or variability in user habits and so on, and that variability impacts the product reliability, right? So in early days, we used to have the deterministic concept. Nowadays, we look at it, no, there's nothing like deterministic. There's a randomness, there's variability in everything. So these two figures I'm showing here, you see those two distribution curves. One represents the strength of the product or the system that we are using, or the capability of the product or service that we are using. And then the second one is the impact, the load, or the demand that you're placing on the product. So your product's capability, the strength, should be much more stronger than the load or the demand you're putting on this. And then both of those are random variability. You see the variability or the distribution curve you're showing. And so what on the left-hand side figure, you see the sort of a pink line is what we call the limit state function. It divides the unsafe region and the safe region. And as a design engineer, we always try to look at the solution within that safe region, because in that region you see the capacity, the load bearing capacity or the demand capacity, demand meeting capacity is higher than the load imposed on it. So for that, we use what we call the reliability-based design optimization, where we try to minimize the objective function by increasing or improving the reliability. You see, the constraint is that the reliability of the system should be greater than or equal to whatever the target, Rij you see over there. And the reliability function, the function G of all of these parameters, what should be the optimal combination of those parameters that my product strength, the load bearing capacity of the product is more than the stress or the load imposed on that. It's a very, very fundamental reliability-based design optimization. There's nothing, new in that people have been using it. But there's another aspect comes to it called the robust design. And this concept was first developed by Dr. Taguchi, who sort of divides, whatever we do, whatever the product, the system we use, design, there are two categories of design parameters or the factors we call them. The one category is called the controllable factor. That means when I design the product, I can change those. I can decide what should be diameter, what should be length, or what material I should use, and so on. I can change those. I can manipulate those parameters. We call them control factors. The second category is called uncontrollable factors. We call them noise factors. And we call them uncontrollable noise because I don't have, as a design engineer, I don't have any control on those factors. All I have is find the optimal setting of those controllable parameters where the system becomes insensitive to the noise factor. I have 50 individuals in this room. Each one of us have the different head, different way of using the product. It's the same. If all of us are driving a motorbike, each one of us have a different head. Some of us are very careful, only not more than 2 people sitting on that, carefully driving within the space. Some of us are crazy. I've got 5 people sitting on the bike and then driving like crazy. I have to keep that in mind. I cannot dictate to customers how to use it. I can tell them how to use it, but still I cannot dictate it. So I have to keep that in mind and design the product. If you see the curve on the right-hand side, we take the advantage of what's called a non-linear function. So if you see the factor A, which is my controllable factor, and on the vertical axis, it shows the output, the performance of, right? So if I change the factor A label from A1 to A2, right? Even though at A2 level there's more variability, it's input variability, right? But you see the performance output variability is useful. All I did is just change the label from A1 to A2. I'm able to reduce the variability in the performance just because I'm taking the advantage of that nonlinear function between input and output model. Right, so if I can understand, if I can find out if there exists a nonlinear function between input and output model, I can find out at what level I should optimize the product parameters, reduce the variability in the performance of the product and so on. So this model basically, and what we are doing here is I'm reducing the variability of the performance. So my objective function is to minimize the variability subject to those functions, characteristics of the product and so on. And these characteristics could be of any type. So it's mostly what we do, we define them in 3 different characteristics. Larger the better size, smaller the better size, or nominal the best. So an example, for example, I'm designing a system where the objective is to reduce the variability subject to some of those product characteristics. And you'll see those characteristics either smaller the better type or larger the better type or nominal the best and so on. So the focus really, what we did is we're combining these two, reliability-based and robust design with the objective to reduce the variability of the product performance, increase the reliability, make sure the product characteristics are satisfying the expectations. Quality loss function, that's another concept Dr. Taguchi is. And it's basically what it says is normally in engineering, in manufacturing systems, we always have what we call the plus minus specification, right? Where the understanding is if your product is within that plus minus range, it's a good quality product. Dr. Taguchi came with that, no, that's not true. If your product is not manufactured on the target, if it's deviating from the target, though it is still in the specification limit, it's not a good quality product. And the example which I give in my class in CPM, your pen you're using, your cap of the pen. So these are the 2 elements, the cap and the rest of the body, and the fit it together. Your cap has inner diameter. The rest of the body has outer diameter. So those are the two specifications. Inner diameter of the cap, the outer diameter of the body, they fit together. Now, from the manufacturing point of view, when the design engineer gives the specification, he will give you the inner diameter plus minus some range, the outer diameter plus minus some range. Now, these two parts are manufactured by two different companies. I'm getting them here to assemble. Now, cap, just imagine the cap has the actual diameter larger than the specified diameter, but still within the specification. It's close to the upper tolerance limit. The body I get is the outer diameter, still within the specification, closer to the lower specification. Both the suppliers say, yeah, that's good quality. This is within the tolerance limit, this is within the tolerance limit. But as a final manufacturer, if I assemble them together, they're not fitting up. But what Saguti said, any deviation from the target is what he called is a loss to the society. Quality loss means a loss to the society, loss to the manufacturer, it's loss to the customer, it's loss to the supplier. So everybody gets lost out of this process, although we don't realize that. So that's what we are trying to do. As an engineer, we try to capture all of those together. What we did is we actually developed a new multi-objective function by using the quality loss concept. And to develop that, we use, as I mentioned, three types of the quality characteristics: nominal the best, which is the target, actual target value, larger the better type, or smaller the better type. So we use those concepts, and you see the figure on the right-hand side sort of giving you nominal the best. It should be exactly on the target. If it deviates from the target, you can see the loss function is varying, right? It increases exponentially on either side of that. Smaller the better type. You want your product characteristics to be smaller, or smaller the better. Keep on it. Like variability. Variability is one of the things that you always want to minimize. That's a smaller the better type. There are some characteristics that are larger the better type. For example, the fuel efficiency of your motorbike. Larger the fuel efficiency, better it is, because you have to spend less money on your pocket and so on. So we identified, and then based on those, we sort of developed the multi-objective function, and we call the hybrid quality loss function. So basically what we did is, any deviation from the target results into the loss function. So objective is to minimize. So that's the function we developed, optimization, a multi-objective optimized model. Subject to these three characteristics, all of the better. And so there's a mathematical model for all of these three characteristics. And then we brought the reliability. Now this one combines both reliability-based design and robust design models, and we call it reliability-based robust design methods. And the combination is again where the hybrid quality loss function, multi-objective function, but then we included the reliability function. You see P of, the mu over sigma, that's the reliability function, and then again, reliability is larger the better type. The objective is to maximize that. And then of course, because it gets more complex, we are using the Taylor series function, right, to sort of normalize it. We took a simple example of suspension system. In the leaf spring in your car or heavy truck, you use those suspension systems and leaf springs, right? So we use that design function. Now we identified four characteristics: the weight, the free height of the leaf spring, spring rate, and then the stress, the load bearing capacity, right? And so basically, I'm using the mathematical models for each of those. Now in this case, for example, weight is a smaller the better type characteristic. I want my product to weigh less. And why? Because if I'm able to reduce the weight of all the elements of the vehicle, I'm reducing the total weight of the vehicle, right? And by reducing the weight of the vehicle, I'm able to improve the fuel efficiency. The mileage, the kilometer per hour increases. So you see, the contradiction. I want to improve the fuel efficiency. I want to reduce the weight. But then there are other consequences. If I reduce the weight, the vehicle weight goes down, the stability of the vehicle gets impacted. So there is always the contradiction, the conflicting requirement that you have to find the optimal scenario where I can reduce those. So basically, we solve that. We use different approaches. We're able to prove that quality loss function based hybrid model of reliability based robust design is far, far better than some of the existing ones. And then the second aspect, which really I'm more interested, I've advanced it more now, is I'm not designing the product now. I want to design the product that I can see it survives for the next 5 or 10 years. Now, to do that, as I mentioned in the morning in my discussion, is I need to understand how the product degrades. That's the way I'm capturing the entire life cycle of the product. So if I know how it's going to degrade, then I know after 5 years what will be the strength of my product, what will be the load bearing capacity of my product, and so on. And then I also want to build that understanding that there's something called variability. So the straight line you see, the degradation is the average degradation rate, but I have those distribution curves. So, no, it's average, but average is always confusing. I never rely on the average. I always look at what's the total variability. So you see the variability in that and so on. So I capture that into my mathematical model and develop the same optimized reliability based robust optimized model. But the challenge here is how do I capture? So in this case, you'll realize this is how the product degrades or the performance degrades. You see the variability at each point of time. So I use those two well-established degradation model, the SN curve, the stress and life curve, and then Palmgren-Minner's damage accumulation model. Combine those, which now gives me if you see the equation at the bottom, the damage, D stands for the damage. Now, damage or the degradation is actually a function of strength or the stress active. So S is the stress acting on the product at any given point of time. And N is the user's life. Small n is the user's life. And uppercase N, F, you see, is the design life. So you see, the degradation of your product at any given point of time is a function of stress under which the product is acting, and then how long it has been used. Now, that stress captures your user behavior, the habits, the way you are using, misusing, or abusing your product. We try to capture that under what are the stress conditions. What are the operating conditions under which the product will be subjected? And if I understand that, so there's an entirely total different research domain where they understand the user behavior, how people behave, how people use. And it's one of the emerging area these days is understanding the societal changes. Because we want to capture that in designing the product. How the expectations, the requirements of the customers are changing, how the society is changing. Because that gives us food to really design new product and so on. And so finally, you see it's the relationship between the operating conditions, the way the product is being subjected to different stresses and operating conditions, and then how long you have to use. So you've seen this curve here, so it shows now other aspects here. So there are two sources of variability. The variability introduced by the operating conditions. So you see that distribution. But then also the variability introduced by the user's life. So we see sort of a funnel shape which is expanding, because as you grow older, the variability increases significantly. So there are two sources of it. How do we capture that? And to capture that variability, we actually use the geometry. So you see the figure on the bottom, we have to really apply the geometry concepts to combine the variability coming from two different sources. The operating conditions, if you see a figure on the top, if the product is subject to the high stress level, the life decreases, right? So you can see, the N1, NF1 is the design life if the stress level is very high. If the stress level is low, the design life increases. So you see, but then also you see the phenomena. When the stress is low, design life is high, the variability is high. If you subject your product to very high stress level, it will fail immediately, right? So the variability, so that's one source of the variability into the product performance, whether it's subject to the high stress level, low stress level, or medium stress level. The second aspect is duration, how long it has been used. And so those two sources of variability we captured by applying the geometrical concept, and that's the equation we got. The bottom, and see here, it shows the variability introduced, the sigma d, the standard deviation. So the variability introduced in your product is a function of the stress level, it's a function of user's life, it's a function of the design life, and it's a function of the variability in your design life. And you will not believe this equation captures almost all of these issues, the concern that I sort of introduced in my first slide. And then by using this, we developed the reliability prediction model. You see here, probability that the damage accumulated at any given point of time, it is still less than the critical damage, right? Because that's my threshold of the failure. And so we developed this model, I call it a dynamic reliability model. If you give me the operating conditions, if you give me how long this product has been used, I will be able to predict the reliability for that given scenario. And so if you see here, different scenarios we consider, different stress levels, and you see how the reliability changes over a period of time. The last curve on the right-hand side, you see, is the product subject to the very high stress level. You see the crack initiation phase is very short, right? Because subject to very high stress level, and then you reduce the stress level. So though crack initiation started at a very early stage, but then the degradation is slower because later on the stress level is very low. The second curve, you see the horizontal line is long because product is subject to a very low stress level. So it took a longer time to initiate the crack. And once the crack started, you put a heavy load on this, you almost see the vertical drop in the reliability of the product. So I'm not emphasizing, but I'm trying to bring it, look, I'm getting this dynamic scenario, but everything is the mathematics behind it. I captured all of those concerns and issues by using the mathematical models to design and predict the reliability of this product. So I think I've been given the warning. I'll stop here. If there are any questions, please let me know. And this is another research work because when I develop the dynamic model, I consider the linear relationship. But in reality, it's non-linear relationship, and that's another thing that we are working now, capture on that. Questions?
Thank you, Professor Yadav, for this wonderful presentation. Area which is very relevant and of a direct impact to the industry. So, do we have any questions from the audience?
that you talked of the objective function and then the followed by constraints. And there were about 7, 8 constraints. Is that right?
Which one?
Constraints was about 7, 8.
So now we had 3 constraints specified 3 different characteristics. You know, the larger the better type, smaller the better type, or nominal the best. And then we added one more constraint, which is a reliability constraint. Yeah. So
there were 4, or I see.
There were 4 categories of the constraints.
So
there were more equations.
So you use some software to. Normally, it's very difficult to solve the problem.
Yeah, no, it's MATLAB. Yeah.
Thank you.
Thank you.
Professor Yadav, you had mentioned about degradation behavior and also about the stress conditions.
Yeah.
So had you chosen some particular sector to test it? Your data was from which area?
So the last one which I joined was the data based on the design of experiments. So basically, we designed the experiments, we performed the experiments, and then collected the data. You know, so that's totally different, separate domain. You know, to collect the data, it's even a different research. What kind of experiment you need to design and so on. I was able to get it because of my connection at Ford Motor Company. I can't do it in university, you know, because designing the experiment for the suspension system, testing, the resource requirement is beyond. But
that's why my question was, because when you talk about stress conditions, testing the degradation behavior, even about your robust designs, you may need real data from industry to test on it. And also, have you taken into your consideration while modeling about the scalability of the designs?
In this case, the scalability is not a problem. The only problem is the data. You know, because this can easily be applied so I was not worried about the scalability in this case. My major concern was really the data.
Yeah. Okay, thank you. So can we have a big round of applause for Professor O.P. Yadav for this wonderful presentation that we had given on a very relevant topic today. Thank you, sir.
Can't hear anything. I can't hear anything.
We have the next speaker. Is Professor Santosh Kumar from Australia. Professor Santosh Kumar obtained MSc Mathematics from Vikram University and PhD Operations Research Delhi University. I have known him since that PhD in Operations Research. He is currently an honorary professor in mathematics discipline at RMIT, Australia. He is also co-author of just a sec.
I now request Professor H.D. Arora sir to honor us by presenting a memento to Professor Sunil Khatri sir.
I now request Professor Sunil Khatri sir to felicitate Professor Om Prakash Yadav sir with a memento. Thank you, sir. Now I request Professor S.D. Arora sir to honor us by felicitating Professor Sunil Khatri sir. Thank you, sir.
Sorry for the interruption. Professor Santosh Kumar is already watching us. He's co-author of 210 papers, oblique book chapters, and 4 books in mathematical programming and network optimization. He has served on the editorial board of OpSearch, Asia Pacific Journal of OR, International Journal of Mathematics, Engineering and Management. His contributions in operations research were recognized by Australian Society for Operations Research by their Ranport Awards in 2009, and the South Africa OR Society recognized by the contribution by their recognition award to him as a non-member of their society and non-resident of South Africa for spreading the field of OR in Southern African region in 2011. He's most noteworthy is he's been president of Asia Pacific Operation Research Society, where ASOR was a member with 7 other countries like China, India, Japan, Korea, Malaysia, and so on. He's a life member of Australian Society for Operation Research, a senior life member of World Society of India, a life fellow of the Institute of Mathematics and its applications. And there are several other achievements. I'm not reading them. That's enough. I have a long association with him. We have been meeting in Delhi University quite often. Only when I left Delhi University, he is not able to go there and stay in the guest house or so on. But his roots are in Delhi, whatever. And his original PhD was in theory of reliability. He shifted to optimization, mathematical programming, and so on. Yeah, I now request Professor Santosh Kumar to give his talk.
Thank you.
Santosh, can you hear me?
Yeah, I can hear you.
It's wonderful to have you today here. It's wonderful.
Thank you, sir. Thank you. And first of all, I want to say that I'm very grateful to you for making me a part of this auspicious day, you see. And my talk is on certain alternatives in optimization often arise, and there are ways of recognizing them. But here in this particular talk, I will be talking about how to create them for the benefit of solving some difficult combinatorial optimization problems. So now, any problem, this is a typical history of any problem, that it is a never-ending challenge. Technology change, problem change, methods, new methods come, and so on. And this will be typically reflected by this particular, in this particular talk also. I take a very classical problem of shortest connected graph in network. It's a very simple problem. It is, the procedure is greedy approach. So I've taken a very trivial example, that is node 1 in this 6 node connected, node 6 is hiding behind it. So if I take node 1 is connected to all other nodes costing 1, 2 is costing 2, 3 is 3, and so on, then greedy approach says whichever is cheapest, pick it up, and if it is not forming a circuit, accept it. So that's how you get the shortest connected graph. So it's a very simple problem. Another associated problem in graph theory is traveling salesman, which is being stated as a very difficult, or it has been even classified as a NP-hard problem. Before we go to this NP-hard problem, let us look into certain characteristics of this shortest connected graph. For example, in n node, you need only n minus 1 links, and therefore the total number of index values, every link has 2 index, so total index is 2 into n minus 1. And this is how we thought about it, that can we redefine the problem of shortest connected graph under certain restriction, that is index on each node is less than 2 or greater than equal to 1, less than equal to 2. And this is another way of saying that we are seeking a path passing through all nodes, between 2 nodes in the network, because it balances 2 nodes will have two particular index values, because from where the links will start, remaining n minus 2 nodes will have something coming in, something going out, 2 index value, and total is back to 2n minus 1, which is the same. So if I go back to the previous slide, this node 1 is a high index value because it has got index of 5. Every link is starting from it. And all other nodes have a low index value because they have got only one link reaching them. So it is not a path. So in other words, we are saying that node 1 is high index. Out of those low index values, 2 are okay because we are looking for a path which will be, index value will be 1, and other 3 are low index value. So we developed a theorem, and this theorem we developed a theorem, index balancing theorem. That is, somehow we have to reduce the index of the high index node and increase the index of the low index node. And how that is done, let me illustrate that. Low index theorem simply says that you can create alternatives. And how we have created alternatives? Because the statement of the low index theorem is that if a node is high index node, and if anything is added to all the nodes, relative merits is not changed. So that is what I'm doing. I'm adding to node 1. Original length was connecting to all other nodes 1, 1, 1. I have increased this value by 1 more. So I'm not changing the relative merit. But this way I have created an alternative. Because now between 1 and 2, the distance is 1 and 4, distance is 2. Between 2 and 4, the distance is also 2. So this alternative, and what the shortest connected method says, is that if there is a tie, you can break it arbitrarily. But we are now going to not resolve the tie arbitrarily, but we will resolve it in a special way. We have removed the node, we have removed the link between 1 and 4 and created a link between 2 and 4. That is how we have reduced the index value of node 1 and improved the index value of node 2. And I continue doing this, repeat this action, and ultimately I obtain a path joining with nodes 6 and 5. And this time you can see the shortest connected network with index value Ni at any node is between 1 and 2. So this was a new problem defined with the hope that it will open up doors for solving the NP-hard traveling salesman problem. So how we go from this to the traveling salesman problem? Traveling salesman problem is a NP-hard problem, and there are other related problems which were in 60s looked at computationally very, very difficult and demanding problems. Now, by this new alternative approach, what we are talking today, this traveling salesman, as well as those other problems like path through case specified nodes, etc., they have also become manageable and they are not computationally difficult. I now come back to this another graph, and suppose I'm looking for a salesman tour. Now, arbitrarily, I have selected node 1 simply because it has got less number of links passing through this particular node, only 3 links, 1, 2, 1, 4, 1, 3. So now by solving 3 index restricted shortest connected graph, I can find the solution to the difficult traveling salesman problem, because I can take one combination as 1, 2, 1, 3, another 1, 2, 1, 4, another 1, 4, 1, 3. These are the only 3 combinations which will be possible. So, in other words, I will modify this graph. That is, I have removed the node 1, removed all the 3 links, and I am finding between this remaining graph, which I describe as G6 minus 1, 13 minus 3 here, because one node is less and 3 links are less. So this new graph is G510. And I'm finding out the connected graph, converting that connected graph to restricted shortest connected graph, and then I'm getting a salesman tour, because 3 salesman tour are the only possibility, because every tour has to pass through 1. So if it has to go through node 1, these are the only 3 combinations. And thereby I establish a tour. Another applications of this is index balancing theorem. Yeah.
Your time is up. You take 2 minutes more to wind up.
Okay.
Yeah.
Well, the idea behind this is that difficult problems can be converted sometimes by redefining, and the concept of alternative has been used as a method for solving the problem. So I leave 1 minute time for people to ask me if they have.
Over? Yeah.
Should I stop sharing?
Can I have a question or two? Anybody interested in asking a question? Please. But your area of real is very difficult, I think. Anyway, let us thank Professor Santosh for good.
Well, give me 1 more minute. I go to the last slide.
Okay.
And what I'm doing is here, I'm creating alternatives and solving again a difficult problem of the kth best, that is ordered optimum. And this concept of alternative is helping me to prove that I can find best and second best at the same time. Thank you.
Thank you very much, Professor Santosh Kumar. Let's give him a big hand. It's excellent to see you on the screen.
Thank you.
Thank you for a long time.
Yeah.
See you soon.
See you soon. Yeah, I will come down.
Maybe we have you through Amity University. Anyway, thank you very much, sir.
Thank you. Thank you.
Yeah, we have the next speaker, Professor D.S. Huda. Professor Huda holds Masters in Mathematics from Delhi University, MPhil from Meerut University, and a PhD from Kurukshetra University. His research interests include information measures, source coding, entropy, optimization principles, survival analysis, pattern recognition, fuzzy sets, and fuzzy information. Professor Huda is an eminent mathematician and an able administrator at Par Excellence. He has worked as member of expert committees of UGC for evaluation of the proposals to organize seminars, conferences, workshops, and special assistance program. He's been a member of the General Council of the Institute of Excellence of Higher Education, Bhopal, and the Board of Governors of Rajasthan Institute of Engineering and Technology, Jaipur. He has received numerous awards for his outstanding research and contributions to information theory, including the International Plato Award for Educational Achievement in 2010. He has also been recognized with the Bharat Ratna, Dr. Abdul Kalam Gold Medal Award by the Global Economic Progress and Research Association. Rashtriya Shiksha Ratan Award was bestowed on him in 43rd International Conference organized by Indian Institute of Heritage, Calcutta from February 7 to 9. Best Researcher Award by the Institute of Technical and Research Committee or something, Jaipur on 13th September 2020. Yeah. I request Professor Huda to take the mic.
Hello. Hello. Professor P.K. Kapoor, my old friend and very lovely person, and all this audience, faculty members, students, lecturers. Friends, firstly, when I was invited to deliver a talk, then I submitted a abstract of a research talk titled Soft Body Drawing and its application in dimension reduction and medical diagnosis. But later on, I thought I had was experience. I had been attending, participating, delivering talks for the last many years, 5 years, continuously. But I see there is a research talk on various topics, but hardly speak on Ramanujan. In the memory of that we celebrated, our audience, our youth, our researchers must know that his life. This is a big talk. I will not be able to do. This is life and contributions. Contribution have been about contribution have 2 or 3 speakers have spoken a little, but there is a scarcity of time. So I will be taking only his life period. Yes, in my talk, I will be talking about birth and childhood. Friends, his life is very interesting. You will see a different type of the person. And you will see whether how this such a person that rose and teaches the world were known. Still, his work is unsolved, I may tell you. That's why his birth and childhood, student life and mathematics education, health and illness, family and friends, visiting. And all will not be talked. I will be talking how much time? Oh, that's right. Then I will be talking only one or two aspects. I will be visit to England, contributions, eclipses of his contribution. Hence, his birth and childhood. Ramanujan was born on December 22nd, 1887 in Erode, a minor city in Madras, and his father was a kelner in a fabric store. The family was Brahman, and Ramanujan's maternal grandfather was a small official in a local court. Although his family was poor, yet it was socially respectable. Ramanujan was born in his grandfather's house in Erode. Soon after his birth, his mother and father moved with him to a house in the town Kumbakonam, where Ramanujan grew up. The family name Ramanujan means a person who contains a particle of the god Rama. His personal name Srivasam roughly means prosperous, more literally one who abides in wealth. But will go Ramanujan's family took him in a student's boarding house, where he was first introduced to formal mathematics. One of the boarders lent him a trigonometry text where he was 12 years old, and Ramanujan himself mastered it within a year. When Ramanujan was 16 and still in high school, an elderly friend who knew of his precocious mathematical talent gave him George Scott's synopsis of elementary results in pure and applied mathematics. After reading and working on this synopsis, Ramanujan discovered that he could find the new results which were not contained in Scott's synopsis. He derived actually in mathematics. The main problem is how to identify the research problem. This is, I think, the basic requirement in research. PhD scholars must know that to identify the problem is the main problem in research. Ramanujan discovered that he could find the new results which were not contained in Carl's boxes. This was the beginning of Ramanujan's mathematical production and set the tone of his research in mathematics. Srinivasa Ramanujan was an Indian mathematician of international fame through the British rule in India. In spite of that, he had no formal training in pure mathematics. He made sustained contributions to mathematical analysis in finite series, number theory, continuous fractions, solution to mathematical problems that were considered unsolvable at that time. Friends, Ramanujan family was poor, as I told you, but very respectable. So he got admission to a local high school where he received training in elementary mathematics. Through some college students who had boarding with his family, he was introduced to more advanced mathematics and began learning on his own. When he completed his high school, he took a competitive examination in which he earned very high marks. Consequently, he was awarded with a scholarship by government college at Kumbakonam. Thus, his mathematics development proceeded well, but he was not much interested in other subjects. Actually, he was so fascinated with mathematics that he did not want to spend his time thinking about any other subject. It is also a fact that other subjects were positively dissatisfied to Ramanujan, distasteful to Ramanujan, in particularly physiology. You know, physiology course requires all the prominent and dissection of rocks, and Ramanujan, being devout Hindu, was appalled at what he perceived as a senseless and immoral cruelty. When the examination came to the end of the year, he did very well in mathematics but failed in other subjects. Consequently, he lost his scholarship. Ramanujan was able to complete a year at another college, Patipa in 1906, where he was awarded another scholarship. However, that scholarship was cut in half when another student applied for a scholarship, and the only scholarship was available, so it was divided between them. In examination at the end of 1977, he again failed due to poor performance in the subject other than mathematics. He has only the interest in mathematics. Other subjects he didn't bother, and I think this is not possible this day. A student, if fails others, is not allowed to continue study only in one subject. One of the Ramanujan's friends, Chendo, went on to inquire how Ramanujan arranged money for food. Ramanujan was a devout Hindu and believed in the gods and goddesses of Hinduism. The story he narrated shows how Ramanujan's culture through its members came to his aid. People of the Tamil Nadu helped him without any definite nourishment. Ramanujan led a life of abject poverty for several years but continued his work. What it means, he was had no soul, but his community, other people, supported him like in anything. So their contribution is very much to make him a researcher. Ramanujan was under pressure from his parents to find some job to, to support himself. In 1907, Ramanujan went for an interview with a man who was a deputy collector of revenue with the Madras Civil Service. His name was Ramaswamy Iyer, and he was a founder of the Indian Mathematical Society. In the interview, Ramanujan told higher of his interest in mathematics and showed him one of his notebooks containing the results he had found. Ramanujan was able to complete a year at another college, Patipa, in 19. When Ramanujan told Iyer that he wanted a job as a cleaner, Iyer thought that Ramanujan might lose his mathematics talent working as a cleaner, and hence he would find a way to help him without a job of cleaner. Iyer gave Ramanujan a letter of recommendation to another Iyer, Professor Iyer, and who had Ramanujan instructed in the past also. So, in December 1910, Ramanujan took that letter of recommendation to Professor Sesu Iyer. Professor Iyer passed him on with a note of introduction to Ramachandra Rao, who was a government official and the president of the Indian Mathematical Society. Rao went through Ramanujan's notebook. Rao then inquired and found that Ramanujan was living in the district of Madras near the bridge known as Triplicane. Rao informed Ramanujan that he would receive some money each month to make care of his expenses, and this enabled Ramanujan to do his mathematical and research day and night. He used to take breaks for an evening walk on the beach and for sleep. And there, what he did, how Ramanujan started to feel insecure and about his future, so he took up a job of the clerical in Madras, Port Trust Office. His pay was 25 rupees only. And Ramanujan worked at the Port Trust Office for only a year. During that time, he worked on mathematics, and a few sheets of his work were sent to the Port Trust Supervisor's office along with some official papers. When sheets were there, you see, one side it was something written, one side it was blank. So he used to take sheets and go to the seashore and used to solve the problems of that. So, dear friends, the main thing is this: here, the mathematics requires only, you see, to do work by hand. Now, the things are changing. The students try to mug up the things. This is not required. If you want to become a good researcher, learn the things from Ramanujan's life. Okay, you should work. You should rather do by your own will. And I have experience of this. I am a school teacher to supervisor. I did everything. And I can't remember. You see, if this habit is cultivated, then you will rise in mathematics. Mathematics only learned by doing. Okay? So this is my message to you. During Ramanujan's field work, he told, and one of his friends saw him gathering up this all this. So his health and illness, this is very interesting. Probably the most misleading aspect of the short biographies of Ramanujan is that they leave the impression that the climate and lack of suitable food in England for the vegetarian Ramanujan destroyed his health. Those factors were not good for his health, but his health was precious long before he undertook the journey to England. His health might be weak due to health conditions in South India and due to the genetic factors. His mother bore several children who did not survive and died in infancy. His generally poor health might have contributed to his contraction of tuberculosis. A student who knew Ramanujan and Satyapa Wallace in 1906 to 1907, Radhakrishnan Iyer had some interesting observation of Ramanujan, that Ramanujan was fair and soft of features as one would expect of someone, however, he was not physically active. Iyer said that Ramanujan was concentrating on some mental task, the pupils of his eyes would disappear. Iyer and others noted that Ramanujan's eyes appear intensively penetrating. However, Ramanujan was not withdrawal of and aloof. He was a genial conversationist and liked to talk about religion and philosophy as well as mathematics. He had only two interests, religion and mathematics. And he was a quite devout Hindu, and the god Narasimha was of a special significance for him. In 1909, Iyer was living in Triplicane, district of Madras. One day, Ramanujan arrived at Iyer's residence by horseback.
Sir, your time is up. Excuse me, your time is up. You may take 2 minutes more.
Okay, and you do that. Okay, I am coming to the conclusion. Okay. A glimpses of his work I have noted, but yes. During his very short life, Ramanujan did a lot of work. Some glimpses have been given by other friends also. Yeah, I wanted to work because short of time I could not do. That was the main point I made. Which was further studied and extended by many mathematicians of the world. In fact, many formulas and theorems given by him are still unproved. It is amazing how he made such wonderful discoveries. He had developed extraordinary skill in solving the problem in number theory. Once there is a, you see, he fell ill. His mentor, you see, Hardy, because I left, you see, to all this section, he visited England. He was selected for a fellowship, and he met with Hardy. And Hardy was, one day, at one occasion, he was, you see, Ramanujan was ill. Hardy went to see him about his and to know about his health. And he traveled by a taxi, and that number was 1729. So when he came to inside, then hear about they start taking talk and all that. Hardy said, I traveled by the taxi number this, but it is simply no significance. Then you see, Ramanujan said, no, this is very significant number. Said, how? This is a number which can be written as the cube of numbers two ways. One is 1 square plus 12, sorry, 1 cube plus 12 cube. Another is, you see, 9 cube plus 10 cube. So this is such a mind he has shown number theory. Understand? So he is so genius. He told that this is the number only which can be then, and there is a number also he found out which can be written as a square of two numbers. But there is no other number which can be written as a cube of two numbers in two ways. So this was the extraordinary capability of the Ramanujan. Sometimes Ramanujan was also questioned about the secret of mathematics idea. This is very important. And formula. In response to this question, what he said, this is very interesting. In response to this question, he used to tell that he got this in dreams. I don't know whether you will believe or not, but why what he said, I am telling you. He used to tell that he got this in dreams from the goddess. And this tells about his spiritual and religious beliefs. तो कहता है मेरे को तो कोई देवी आती है और वो बताती है. I don't know whether. According to Professor Freeman D. Dishonor, Gaidon, from the Institute of Advanced Studies of Bristol University, this professor has told that it was a matter of astonishment that Ramanujan discovered a lot and left a lot for future generations to discover. Because there was lack of time when I was with glimpses of his research, and I would have told that briefly what he has done and what is left. Anyway, I express my thanks, Professor Arora, giving this opportunity to come and deliver this talk. Another advice is here. This is a symposium to commemorate his birth year. So I will suggest that at least one speaker should be there, though I could not speak. Might not be, which requires many things to tell, but I could not do time. So anyway, any question, please? Anything? Thank you for all. Thank you.
Anybody wants to ask a question?
Thank you. I express my not only thanks, I express my satisfaction that is very good for the but time should be taken care because time is valuable. You see, that was without inaugurating person, much more time was good. So we keep this, and particularly one day, give a specific area of talks because it is good because there were two talks this way. One was reliability, second was graph theory. So this is also helpful. To make it a, you see something we can gain, students they gain, fruitful, we can say. So this is my advice. Being elderly and all is what I will consider, but I will. Anyway, I am very happy to see your beautiful university, and I thanks and Professor to read Professor P.K. Kapoor, who is very old man. Though we are old, but then also. Thank you. Thank you, sir.
Thank you so much, sir. Now I would request Professor P.K. Kapoor, sir, to present the memento to honor Professor D.S. Huda, sir.
Yeah. ये होता है इधर वाला रेडी होता है ये क्या करके चला जाता है ये जाता है ये होता है
Yeah, hello everyone. Just for, something came to my mind. I thought I'd speak when I give my talk, but I think this is the best time to say that. I want to share with you that for soft availability area, engineering, those who, especially who's doing MIT, Professor Vijay, and little bit maybe Aurora. We started, yeah, something with, yeah. So when I think personally, we were the first to start this start working on research in this area way back. Maybe it was 90 or something. Nobody had, by this time, had done anything in software reliability engineering. And then when I had 10 students, 20 student after student used to come. And by 10 years, we finished all the bloody problems. And they got published, some in good journals, some in mediocre and so on. But idea was to publish everything. But later, those who joined us later in this area, I found they were looking at those papers which we had written 4 years back, 10 years back, and so on, but not referring to those that. I used to feel very upset that sometimes even my own students won't refer to my work, they would rather refer to works by somebody in US, somebody here, But this tendency in our Indian students, Indian faculty, to undermine their own people, is really bad. That you don't want to give citation of your fellow faculty who's done similar work, but you don't want to give a citation, anything of that sort, Ignore. I don't know why this happens. In fact, the journal that we have now, International Journal of, what is the full name? System Assurance Engineering and Management. This journal I started personally from Delhi University because I was so angry with one of the reviewers that I said I will not publish the paper. I'll write this paper directly in the book. And that book was published way back in 92, World Scientific Publication. And it is well quoted, but the idea remains same. People don't refer. Your own people do not encourage you to give citation of their own their work. I don't know why this is happening. And then we started this journal. Now I'm flooded with offers. It is now impact factor of 2.0. People come day in and day out. That sir, please can you publish this? This is the reason my PhD stuck. I said that we started this journal with the aim to help our own students and faculty members who are pursuing research. That was the idea. Still, I keep it to that. But then half of it is gone. The Swedish guy, he was one of the editor-in-chief. He says, let me have half of it and go to Sweden. So now I'm the only, he remains the editor-in-chief, but the money part, he has taken over. I'm not bothered about that. But please ensure when you write a paper, you should rather quote your own faculty, colleague, student. This time we wrote a paper accepting the results of one of my students. So there is no harm. Research knows no boundaries, that you are a teacher, therefore you can do good research. Just forget that. So therefore, the idea was why I got up that I want you to be more concerned about your own fellow countrymen, researchers quote their work, they get a good citation. Somebody saw my citation, he says, because as per your work, this citation is much less. H index is much less. I said, I don't go around to people and ask them to cite my paper. I have seen some faculty who go around and force people to cite their work. So this kind of thing, this is the idea is that way back what we did in early late 80s or early 90s, people are doing now and hiding that. They are not citing that work. And they are citing some other way, so, which has no relevance today. So this is what pinches you most, that you've done a work way back, and this guy is doing now, and still he doesn't have the courtesy to quote this. This is not happening to me alone, it is happening to everyone, those who are working. It is true for everyone. Sometimes maybe some of the faculties does that his own student, for example, I'm saying it in the open, this paper, we did a result on my own student. We published 2 more papers. In both of the papers, I asked her to be the author, so that you don't say that I published first. Your reference is there, but if you feel we can write your name. For us, for me, it doesn't matter whether I have 300 papers or 301 or 305. For me, it is not important to have citation or not, how good is the impact factor, and so on. In good old days, we never bothered about citation index. The impact factor of the journal, just published. Ask Vijay what he was doing 15 years ago. He used to publish in any damn journal, any book. Yeah, I'm sorry. I got yeah, online. Thank you very much for listening.
Thank you, sir. Now we are pleased to extend a warm invitation to Professor Mohammad Samsheed, sir, for an invited talk at the upcoming event. Professor Tamsir's expertise lies in the area of teaching and research, particularly in partial differential equation and numerical analysis. He has currently affiliated with Jazan University in Saudi Arabia. His notable achievements include receiving the Research Excellent Award on December 6, 2018 and on May 28, 2015, as well as a Research Award on May 14, 2012, all in recognition of his meritorious research performance at Graphite Era University. Furthermore, he secured an impressive All India rank 44 in the Graduate Aptitude Test in Engineering in 2008 and qualified for the CSIR JRF in Mathematical Science in December 2007. In terms of his educational background, Professor Tamsir obtained his PhD in mathematics from DDU Gorakhpur University in April 2017 with a thesis titled Numerical Treatment of Some Physical Problems Governed by Partial Differential Equations. We believe that Professor Tamsir's wealth of knowledge and achievements will contribute significantly to the success of our event. We eagerly anticipate his participation and the valuable insights he will share with our audience. Over to you, sir.
Thank you. First of all, I am very thankful to Professor S.T. Arora and his team for inviting me to connect with this wonderful occasion. So now my topic is okay. reconstruction of a potential coefficient in the real equation with non-classical boundary conditions. So here we reconstruct the potential term with non-classical boundary conditions from the additional measurement. Although this problem is ill-posed but has a unique solution. So first of all, we will discuss to solve this direct problem with the cubic B-spline collocation technique, and then we will solve the inverse identification problem with the by using the Tikhonov regularization parameter technique. So here, yeah. Yes. So the problem is this del square u over del t square minus del power 4u del t square del x square minus del square u over del x square equal to atu plus f. Here atu is the potential term and ux comma t is the temperature. So we will consider this initial conditions 2 and boundary conditions 3 and 4 with this additional conditions, additional measurement, this equation number 5. This ux not t equal to ht. This is the additional measurement, and we will suppose that this equation number 2 to 5 are compatible conditions. This equation number 6. So further, this theorem conditions a1, a2, and a3. So if any solution, exact solution, is satisfied these all three conditions of this theorem, then there will be a unique solution. So now we will start the cubic B-spline collocation technique. So here we consider this cubic B-spline function equation number 7, Bix equal to 1 over h power 3, x minus xi power 3, and x minus xi minus 2 power 3 minus 4x minus xi power 3, and third in the interval xi plus 1, xi plus 2 minus x power 3 minus 4 xi plus 1 minus x power 3, and in interval xi plus 1, xi plus 2, xi plus 2 minus x power 3, and 0 elsewhere. So we will consider that the approximate solution is a linear combination of the cubic B-spline basis functions and this time dependent unknown quantities, and we can write this by the equation number 8. And because this cubic B-spline covers 4 elements and each element is covered by the 4 cubic B-spline functions, so the variation of uxt over the element can be expressed by this equation number 7. And then expanding this, we will get this equation number 10, uij equal to ci minus j plus 4cij plus ci plus 1j, and the derivative of uxij equal to minus 3 over delta x ci minus ij plus 3 over delta x ci plus 1j, and the second derivative is this by equation number 6. So this we will get ux and uxx by the collocation technique. So now we will discretize the problem 1. So here time derivative is discretized by using the finite difference method, and in the special derivative we have used Kerensky-Colson technique. So we will get this equation number 13, and then simplifying this and rearranging the terms, we will get this equation number 14, uxx ij minus 1 plus delta t square over 2 gi plus 1 plus gij, and I from 1 to m and j from 1 to n. So now this for j equal to 0, we will because this is at the time j plus 1, j and j minus 1, question number 14. So for j equal to 0, we will use the initial condition, and this equation number 14 will convert into this equation number 15 for the time equal to 0, and for other time j equal to 1 to n, we will use the equation number 14. So now we will use this some notation to simplify it, and we can write this previous equation number 15 in the simplest form, a1 bar ui1 plus B naught bar Uxx ij equal to D naught bar Uij plus E bar Uxx ij. This is at time j equal to 0. So now we will use the values of U and Uxx approximated by the collocation technique. We will use in the equation number 16. And after using this in the equation number 16 and then simplifying the terms, we will get this equation number 17. A1 bar plus tau 2 B naught bar Ci minus 1. This is at time 1. This equation number 17. And this I from 1 to m minus 1. So when I equal to 0, so and I equal to m, then we will get two nodes Ci minus 1 and Cm plus 1, which is outside the boundary. To handle these nodes outside the boundary, we will use the boundary conditions. And similarly, this equation number 14, and by supposing this some terms, we can write this in the simple form as equation number 18. This equation is valid for j equal to 1 to n. And in this equation, again, we will use the approximated values of U and Uxx from the collocation technique, and then using in this equation number 18 and simplifying the terms, we will get this equation number 19. So this equation is valid for all j except j equal to 0, means when time 0. So now we can write this boundary conditions. We can approximate by the same method, collocation technique, and we will get this equation number 20, Ci minus 1 plus 4 C naught j plus C1 j equal to 0. And from the non-classical boundary condition, we will get this equation number 21, and solving this equation number 20 and 21, we will get the values of C minus 1 in terms of C naught and C1, and the values of Cm plus 1 in terms of Cm minus 1 and Cm. So when we will use I equal to 0 and I equal to m in the previous equations for both when time is 0 and time j equal to 1 to n, we can remove the nodes which is outside the boundary by using this equation number 20 and 22. So after removing these nodes from the previous equations, we will get these equation.
Hello, this is, sorry, the time is up.
Yes. So I want to show some results.
Want to take 2-3 minutes to wind up? Go ahead.
So I'm not going in detail for the discretization. So from here we will get the system of the linear equation, this 26, and this system of equation, this 28 and 29. So solving this system of the linear equation, we will get the solution of the direct problem. And then this is the stability analysis. So here also I will not go on the details. So I'm going to the results. So now we will consider the this inverse identification problem. So here we formulate this inverse identification problem by the regularized nonlinear Tikhonov minimization function number 38, which we can write in the discrete form as equation number 39. So now from here, we will use this RMS error and we will use this perturbed data H. In place of this additional measurement, we will use the perturbed data. And here P in the equation number 42, P is the noise. So because this is the ill-posed problem, when we will insert the noise, there will be the large disturbance in the solution. So we have considered these some initial approximation, means input data, and we have this considered the exact solution 45 and this 46. So first we will solve this with the smooth identification function, potential function, and we obtained this some errors. So you can see here this error by the graphs, absolute error. So when we are increasing the mesh size, the error is C going to 10 power minus 3, improving, means reducing error. So now we will solve this for the inverse. This initial gas for the potential term, we will consider this initial gas A naught equal to 1, and we fix the mesh size is 40, and then inverse identification problem, we solve this, then see the results directly here. So in figure number 2, you can see this is the results when there is no noise. So you can see there is a very similarity in the exact and numerical solutions. But in figure number 3, you can see here, when in figure A, first figure, where there is no regularization parameter, then you can see there is a very oscillation in the numerical solution. And when we have used in the figure number 2, when we have used the regularization parameter 10 power minus 8 and 10 power minus 7, then solution is started to stabilize. So going near to the exact solution. Similarly, second term, here figure number 4, you can see when we are using no regularization parameter for the noise 0.01%, then there is a large oscillation in the numerical solution. But when we are using the regularization parameter 10 power minus 7, 10 power minus 6 and 10 power minus 5, so you can see the solutions is started to stabilize, and when 10 power minus 5, then solution is very near to the exact solution. So because this problem is ill-posed problem, so when there is a small noise, there will be a large disturbance in the solution. So we need to regularize this solution. So for that purpose, we need to introduce the regularization parameter. So now the second problem we have considered for the non-linear potential at equal to 1 plus 2 pi cosine square pi t. And here initial guess we have taken a naught equal to 1 plus 2 pi. So now we started with solution, and then see here in the figure. See figure number 5, this solution is without noise. So here is a very close numerical and exact solution. When we have inserted the noise 0.01% in figure number 6, see there are large oscillation in the numerical solution. And when we started to regularize it, inserting the parameter 10 power minus 8 and power minus 7, then solution is started to stabilize very close to the exact solution. See for the noise 0.1%. So when there is no regularization parameter, means lambda is 0, then there is large oscillation, and when we start regularize it, then the solution is started to stabilize. So now I am concluding the results. So here when we inserted the noise 0.01% and 0.1%, then there is a large oscillation in the numerical solution. And when we introduced the regularization parameter lambda equal to 10 power minus 8, 10 power minus 7, 10 power minus 6 and 10 power minus 5, then for these parameters the potential term AT has giving the stabilized solution. And the stability is due to time. Last time I did not discuss, but this showing the direct problem is the method is unconditionally stable for the discretize of the direct problem. So these are the references which I have used here. So now if any question you can ask.
Yeah, any question, please? Ask. I think you should, the young guys should ask anything relating to subject or topic. Any question? Yes. Yeah, there's no question. Then let us applaud him for his good presentation.
Thank you very much.
See you again. All the best.
Thank you so much, sir. Now I request Professor H.D. Arora, sir, to honor us by presenting a memento to Professor P.K. Kapoor, sir. Thank you, sir. I stand here with a heart full of gratitude as we acknowledge and appreciate the invaluable presence of time dedicated by sir at this remarkable event. Your presence has been guiding light that illuminated our path throughout the entire gathering. Now I would request all the dignitaries and the faculty members to please move forward for the lunch. And the poster presenter students may go to F2 firework for their presentation. Thank you.
So I would like to introduce Professor P.K. Kapoor. He is currently Director of MIT Center for Interdisciplinary Research, MIT University, Noida. He has been the former Dean of the Faculty of Mathematical Sciences and former Head of the Department of Operation Research, University of Delhi. His vast research experience in the area of software reliability, optimization, innovation, diffusion modeling in marketing, and multi-criteria decision-making, MCDM, as a tool for interdisciplinary research in human resource development, marketing of brands, big data projects, adoption, and other areas of management. He illustrated his work with over 42 PhD and 25 MPhil scholars. He is an author of two books titled Software Reliability Assessment with Operation Research Applications with Springer, UK, and then Contribution to Hardware and Software Reliability in 1999 with World Scientific, Singapore. And he is editor-in-chief of International Journal of System Assurance Engineering and Management. He is the series editor of book series Asset Analytics, Performance and Safety Management, published by Springer. He has executed various research projects from UGC, DRDO in the area of software reliability and innovation diffusion modeling. He has been the president of Society of Reliability Engineering, Quality and Operation Research Management, SREQOM, since 2000, and former president of Operation Research Society of India, ORC. He has edited 7 volumes of conference proceedings and special issues of various international journals. He has over 350 research papers, publication in top international and national journals, proceedings. He has delivered several keynote addresses, invited talks in various prestigious international and national conferences, and has been invited to deliver lectures in international universities in Sweden, Denmark, South Africa, Serbia. He has been recently awarded with the Best Teacher in Operations Management by Bloomberg and UTV and Lifetime Achievement Award for Global Leadership and pioneering contribution to the field of software reliability engineering, along with an award for his dedicated contribution to the development of DQM Research Center, Serbia, June 2014. Sir, it's my honor to be here to listen to you, and I'm thankful to you that you are here. I would like to invite you for the talk. Please come.
Yeah. Yeah, good afternoon. This is now, I hope you enjoyed your lunch. And I hope you enjoyed the talk too. But I'm not feeling so strong, motivated to talk. Maybe after the food, my thinking changed. However, I will speak. But I may not be at my best. Bear with me. But today I'm talking of something. This interdisciplinary research is also become very common, but not many people use that concept. They may be doing interdisciplinary, but they do not use the word interdisciplinary. But this is a pretty old this thing. This it so happened in our department that some professor was retiring, and I was very eager to teach his paper, which was marketing, Allahabadi. Everybody doubted that why he is interested in marketing when he's already got one or two papers. But I said, let me teach. But the day I started teaching, it was full of models similar to, I saw the syllabus and one of the books and notes. I found that models developed in this area are similar to models that we are developing in software reliability. That motivated me more that once I write one paper in software reliability, automatically I write another in. So at a time we are writing two papers. That's why students were very happy. Research was taking in two folds. Do one problem, solve, get one free. So this was, and then I got so deep into it that I think even in our department, if you find most of the people have used sometime or the other BAS model, diffusion model, for some purpose, this thing. It has become very popular. So I'm in fact left out now. But however, I will, maybe you pick up a new idea. Idea is, this is, I give a little background of software reliability, or you develop a model in software reliability engineering, and then go on to show that how it is similar to a model in innovation diffusion, or what you call marketing, or it is also called, what is that? This general also, there's a technology, what is it? Sorry? Technology forecasting and social change. So it is also named that. So this is, let's not talk too much of English or anything here. Way back, we developed a model in 92. Published in a computer prestigious journal. I didn't know it was, then it came to, it was published in IEEE. It is cited, but that time when we developed every model that I have developed, helped in developing, it has a background. This, for example, background of this there was one professor at GNU Permission. You know that? Yeah. He had come to our department way back. He's retired now. So he gave a lecture and I was listening. The moment he wrote that equation that I was using in software reliability, he was talking in terms of technology forecasting. But when I saw the equation that he wrote, I said, yeah, here, that's enough for the day. So I decided, I was about to leave, then he called me. I said, I don't want to listen anymore, not two problems a day. So this is how, and he didn't like when it got published. He saw the paper, he says, you didn't thank me. I said, did I ask you anything? If I had come to take your help, you had the right if I don't write your name. So this went on, then he was very clever with me now, that this guy is now picking up here and there, So this is how it was generated overnight. We wrote this paper in 7 days. My student was with me. And this was also writing a paper in 1 week. It got stuck in publication for 1 year. So this is also a tragedy, But the people kept asking, what is this, what is that? some simple equation you were not able to interpret. So then I realized mathematics, if it speaks, we must know the art of making mathematics speak. Because the moment you don't speak anything, then what does this stand for? What does this mean? What does it cater to, and so on? Then only you will enjoy mathematics. But my mathematics is that I have been using is not a very difficult mathematics. Is a graduate level mostly. Business school, if you really see, they do not like to use complex mathematics. And I'll show you the paper that which was written by a business school faculty. And when you read that, you're not able to interpret. The meaning that he gets out of it, the meaning that you get out of it is totally different. So this is their process, their way of doing things and doing mathematics and so on. So this is, yeah, he's already reaching the end, this is, can you show the first equation and then we come to this? Yeah, this is the famous equation given by Bach. This model is, this software is given by us without knowing that there is an equivalent model in innovation diffusion. We didn't know. When we developed this model, we didn't know. It was published. And then later when I started teaching, then I realized that there is this model. Then this is one, this one, and we saw that and then school, then we write a different architect combination with that calculation of one big one, it is equation, the rate, the reflection rate minus the remaining flux, and we do the risk substitute this we get the solution and the authors and so this is that this equation can solve one term equation, not two terms, which are we are so this is so the next one. The general norm shown is nothing but d by dt empty. The number of faults detected rate of that is equal to bt, detection rate per bug per error into 80 minus normal. 80 is general now. This around this equation itself, I think 50 more than 50 papers have been written around this equation. And now, Sakshi and all, she did a paper published in technology forecasting, and it came to me, and then I called her. Then I said, I want to do 2-3 papers fast. You have done one, you want to be partner in that because she had initially thought she should be part of this. So she agreed, and immediately we wrote 2 papers, both were published in Annals Collaboration Research. So we were very happy. And still 2-3 are in the pipeline, but I'm not getting a student who can type and write and do the estimation and all. But this is you see the BT and AT. This is point of attack. Now, initially, when we didn't know anything else, we done this paper 90s. Imagine 92, 94, 90, something like that. I published the first book in 92. It came in print in 92. We started working on it maybe 89, or there was nobody to type the paper and book and so on. Latex, that time they wanted it in latex. Nobody knew. I don't type at all. The moment I press a button to this day, I said, I cannot do that. I find it waste of, even when I pay my income tax, I never read that. I don't sum it up, money, where it came. So my sister once said, you will be in trouble one day. I said, let us see. And then, so if I have faith in, I have full faith in my students who are doing PhD with me. We spend time together 2 hours, 3 hours, 1 hour. So relations become different. If I don't trust them, whom do I trust? I'll tell you. If he cheats me, if he does something, the others will tell him what the hell we are doing. Other scholars who are working, they take care that this guy doesn't do that anymore. So this is a group, more than half are with you, the other half, and so on. But anyway, so you see the case one, we started putting the value of 80 way back 92, 89, 92, something like that. So we gave this, there is a solution empty. I'm not telling anything on estimation and so on. I'm only emphasizing on how to model a good create a mathematical model, and which is very realistic. People don't find mathematical models very realistic. As a result, some people do not have interest in doing that. So this case one was done first, and so on. We put the second case two is here, A into 1 plus alpha t. And case three, if you look at that, you should have one demand curve and equation. If you at all use demand curve, use that one. Normally you keep using the same exponential or something. But fourth is also written. So we got this ready and we went to the conference in Dwarka. Some ordinary conference in mathematics. द्वारका में कॉलेज है ना इंजीनियरिंग क्या कहते हैं नहीं अभी भी डायरेक्टर होते थे पहले इसका नाम क्या था NSID. So we read the paper, the whole group, 3, 4, 5 people had gone, Jha was one of them. So then we finished and they said the book will be ready. We never bothered because we didn't believe that we have done a good work. This is good work. We thought this is not enough, good enough to keep track of this. So now after 20 years, with this background, whole background, Sakshi wrote that paper. With a change, I'll show you, you add 2 pages more of mathematics and 10 pages of computation, estimation, graphs, and so on. So together it becomes, and I've read the comments of the, I hope are you with me? They're students? Yeah, they are students. Yeah. No, this is very useful problem. I went to, as far as bits planning, some engineering boy came, he was doing a product. He says, how can you do it? I did it. I said, this is how you proceed. He was very happy. For project work, these kind of models are very useful. And don't ignore that. This is $1 million model, basically. People, yeah, no, because half of it came from somewhere else, and the one I'm coming to, this is now the famous. During your time, Jackie wrote 2 papers with me, using that demand function. And he was so excited. Amit Bardhan was one of the authors. Amit Bardhan went to his house. He said, I'll do it in the evening, sitting at home, which paper lena tha. He sat there, made the paper, came back to me. He says, this is the. So immediately we sent it to Amritsar, that time. I said, let it get this time, that you can apply inventory and other things. So this is all. So this is when I started teaching, what do you call marketing. So this is that that you have the innovation. This is the beauty of the. I spoke once 1 hour on this graph. When I started with that, so I spoke 1 hour in a college, many colleges, 1 hour, and with this only the diagram. Too many stories, and so this is also simply this is innovation. Something new which you develop, you see, is an innovation. For me, something may not be an innovation. For him, it may be an innovation because I've already seen it actually, but used it actually. So anyway, but roughly speaking, something which innovation is some new idea, anything. That's all innovation. So it could be a product, a new car came. This is an innovation. But the engine may be somebody's engine may be same. The body, what is a car? Many of them have the same engine. And also conversant. If it is the body they change. Some say this doesn't look nice from this side. This criticism will come sent to another class name. So this kind of. So anyway, there is innovation passes through a communication channel, print media, any media. Communication is you do through word of mouth, you do through advertising, you do it talking to friends and relations. Develop that idea, communication over a period of time, it reaches the social system. A product that you have developed now, a product which is an innovation, if it has just come, or it through the communication channel over a print media or a visual media or whatever, it over a period of time, how it reaches the required audience. So every input, every innovation is not useful for every set of people. I have a different requirement. He has a different requirement. So therefore, your social system keeps changing. So the equation that was written that time, I say, this is the equation. This is a management science. Imagine this paper is published in management science way back in 90s. I think the author himself said that I didn't believe that it would become so popular. But if you really see things and mathematics models become popular, where you think you have no idea, you certainly find somebody said, many people are citing it. So this is also you tag on to something which attracts you and don't leave it. So this is my idea of research. Research it doesn't happen every day. So anyway, this result was already there when I exactly same, mathematics same, only the parameters speak in different language. And parameter is something error detection rate per error, adoption rate, and so on. Even repeat purchase was a problem in this innovation diffusion. People did it long way and nobody picked up. If you really see, if you've done a VAST model or a technology forecasting model, you find the repeat purchase is not commonly done. Whereas in software reliability, fault introduction, you do in every paper. It is not, and that idea was also picked up from there and used in this. So there are two areas going together. One is our own software reliability engineering. When we brought in software reliability, people were so angry. They say Kapoor is doing everything for his future or something, to make his future safe or, good or peaceful or whatever. So I did some hardware reliability too. We didn't give any. That time we used to write and publish in any. You are doing a conference, let's go there and give it 40, 50 line like that. And people are using those papers to develop their own model, and they don't refer. And some luckily, if they refer to some paper, they in the reference also I find this is very funny that a teacher allowed that Kapoor 14 very small or Kapoor is missing 14. This I can show you that paper that way back we did, and he made it so big, unbelievable, that the same thing he's writing in, we had written in few pages, 5, 6 pages, he took maybe 15 pages. So the problem is that why I asked Vijay and Aurora, you want me to solve the equation. I've never done undergrad teaching. I stayed from undergrad, I did the books and I stayed away, went abroad. When I came back and he did a job, I got in the department. So the stuff that is taught in undergraduate level, I do not know. So that's when I need help, I call this guy, I said, take this, take that, and you come and sit with me. I literally go and take them for something, a coffee, and then you come back here, you solve career equation. Then he is not understood still. प्यार से कह दिए कि अच्छा मैं भी करता हूँ, But later, the people come to know that, but it's not misusing. I also put his name somewhere. So therefore, what else you want? You are an author with a new idea in a paper, a new idea which is going to be published. So this is where I said people are saying this, that if you do something, if you are the first to do something, people recognize, may or may not recognize, give you recognition. The other paper I showed you, innovation division, that guy didn't bother. This is one that in the white guys, they have one thing is honesty and sincerity. If their colleague has done a paper, they will make sure that it is cited. Whereas here in India, I see his paper. First I want to see the reference. Did I cite my paper? I find no. Then I check whether my book is cited. No. Then I telephone him. I said, you wrote a paper. You didn't even cite the book. You're citing for same thing. You're citing the foreign author's book for the same thing. So why don't you cite this one also? You will cite both of them. So this is the tragedy, So I make sure I do not do this, and students get that feeling that sir is also hiding this paper or that paper. I said, let it be there. My one paper was the teacher was not publishing. I said, don't publish, I write the book. You read that book. That first book, 92, I put the finger, and then years to type that in latest. He said, he's an author. He did the latest. He typed that book. He's also an author. Imagine. What more can I do? No, either I would have given up, but I wanted because the reviewer of the thesis, it came from thesis, students. The one who reviewed that thesis wrote so good about that I didn't want to miss that chance. I said, write this book. But it's all the light of the day, but it still has 300 people are not citing much, though, because I combine hardware reliability too in that. It is very small font, which is not easy to read. Anyway, but this is the background that I kept doing, and so this is, and now of late what is done. You see that the same thing you can do. So with one model, you can write 20 other models. Change this, change that, change this, change that. Add something from your own side. And then you find, again, same cases were done, and these were done later. This was done by, we had done, but Sakshi decided to do. So if you really see, this is, yeah, various, this is the paper by this also everybody feels happy because technology forecasting this paper maybe this is genuine, right? It's over. This I can speak 10 hours. Time up. Yeah, I'm one of the hosts. I can go and speak in but I think you are not listening, and you want me to stop. So anyway, this is just I'm sharing. Just show that equation. Again, empty. Yeah, this is the change. We are which 1 to 2. The inside, the empty. You see the empty. This is the potential front end. Marketing, we call it potential number of customers who will buy the product. So this one, it we also had several forms, but this thing, this potential adopters. Oh, they change and then change to stochastic equations and so on. And already we done. Now we should show that convolution. This is the general form. But if you see that last one that we saw, last with the F convolution G convolution F. So before anybody else, we thought G can't get. We not only extended that you buy the product, you are first made aware of the product. But only people, you see, this is difficult to create the model. So this helped us, and that enters in the guy. Instead of G alone, now you have H convolution G. So H stands for awareness distribution, and G does the same as before. So this is also, so mathematics is not very difficult. SPSS and so on. This is of late what we are doing. It's going on. But the question is, I have many, they think nobody, a student doesn't have the time. Either to solve, either, they go to private colleges to teach, then there is no time left to do research. Otherwise, the problem is begging a solution, and you are not ready to do. Literally, I called Sakshi sir, very doctor. What is his name? Saurabh. उसने अपने thesis का काम करके भाग गया. As soon as he finishes, he's आऊंगा. So this is students are also no less clever. And depending on Vivek. Yeah. Okay, thank you very much. Thanks for your indulgence, patience. Thank you.
So thank you very much, sir, for your valuable talk and from the ground. Please sit down, students. Sit down. Others. Okay, next we have any questions?
So thank you very much, sir, for your valuable insight on the diffusion model from basic to advanced. And now I would like to invite the second speaker. I would like to request all the speakers, please be crisp and take minimum time. So because we are running short of time, I'm sorry for that. So next speaker is Dr. Aditi Khanna. Aditi Khanna started her academic career with University of Delhi in 2007. Currently, she is working as an associate professor in Department of Operation Research, University of Delhi. She completed her PhD Inventory Management in 2010, MPhil in 2004, and MSc in 2002, all from Operation Research Department, Delhi University. Her research interests lies in the area of inventory and supply chain management, production planning and control, sustainable development. She is life member of Operation Research Society of India and Association of Inventory Academicians and Practitioners, AIAP. She has published several research papers in international journals, including Journal of Linear Production, Business Strategies, and many other reputed journals. She has guided 3 PhD scholars and 5 more students are pursuing their PhD under her supervision. She is a member of editorial board for Green and Low Carbon Economy, editorial review board member for MIT Journal for Operations Research Management, and has served as a guest editor for a special issue of Emerging Trends in Inventory, Supply Chain and Reliability, Modeling in Yugoslavia Journal of Operations Research. She has actively participated in many international conferences and academic committees of university, and has also been a member of committee of courses to review and revise various levels of operation research papers, PG and UG programs. So I'm thankful to her that she is here. I have done so many research papers with her. So I would like to invite Aditi Khanna, please, for her invited.
Thank you very much for your kind introduction. So today as we are So today we have gathered here to celebrate the National Mathematics Day. So what is the contribution of mathematics? Obviously everyone knows in wide areas it is applicable. Today I would like to share with you how through a mathematical framework we can go for sustainable development in production inventory systems. So to start with my talk would have the following contents. We will talk about sustainability. What are the major challenges faced by sustainability in context of production inventory systems? Then how to minimize the harmful environmental impact and what are the benefits of a sustainable approach? So sustainability, as we all know, refers to the ability of our society to survive and grow without depleting all of the natural resources necessary to sustain it for generations to come. A sustainable inventory management approach aims to reduce the impact of inventory and production related activities on the environment and society without affecting profitability. So what are the major challenges in context of production inventory systems we face? That is overstocking and understocking of goods, greenhouse gas emissions related to manufacturing processes, transportation, defect of waste management, limited circular economy practices. In production inventory systems, there is still a lot of scope for circular economy practices like product recovery, resource recovery. Then limited use of renewable sources, like in production systems, all the systems are majorly working on fossil fuels. If we shift our base energy base to renewable sources, we can go for a more sustainable future. So GHG emissions, obviously all of us know, these are the alarming topic of today's era. Not wasting much time, the time is less. Majorly, I would like to just make you aware that the fashion and its supply chain is the third largest industry after food and construction, which is responsible for greenhouse gas emissions. If it continues at the same pace, the industry's greenhouse gas emissions are predicted to increase by more than 50% by the year 2030. So obviously, by this data, we should be alarmed and we should go for the techniques or the practices that advocate sustainable development. So apart from industrial processes, we all are familiar with the production processes, transportation, they entail the greenhouse gas emissions are responsible for that. One area that is less explored is the defect management. Defectives that are the byproduct of the industries or the used products, they are directly disposed to landfills. And when these landfills are burned, they are responsible for very toxic substances, which are 28 times more potent than carbon dioxide. So this area needs an urgent attention. That is less explored in context of production systems. So to how to minimize this environmental ill effects, obviously a holistic and collaborative effort is required. Today I would like to talk about these 4-5 concepts in my research that I have incorporated. Flexible production system, renewable energy, green technology, defect management, and product recovery. So let us go through briefly through what do we understand by this and how we can implement this. Flexible production lets manufacturers adjust their production volume, production rate, runtime, and product types quickly to match the market demand. So if we are able to optimize our production rate, we are in a more good position because we are not overproducing or underproducing. So flexible production systems allow us to avoid overproduction, stockouts, and inventory related cost. So this is a part of sustainable framework. Coming to renewable energy, nowadays there are many awareness programs and government is also promoting the use of renewable energy like solar energy panels at home also. So industry should also go for such sources of energy in spite of coal and gas or petrol, the traditional forms. So there are many sources like solar, wind, geothermal energy that we can use in our production systems to switch to a sustainable stage. So it helps in mitigating the environmental impact, reducing greenhouse gas emissions, improving energy efficiency, and advancing sustainability. Coming to green technology, a little difference from renewable energy. The examples include energy efficient appliances, plant-based packaging, sourcing organic raw material, going for biomass or biofuel, e-waste recycling, waste management, electronic vehicles, carbon capture and storage technology. This is something new that is being implemented in New York. The carbon capture and storage technology. That means whatever the carbon emission we are emitting, we are storing it somewhere and utilizing it in some other fuel. So this is a part of green technology. It is a broader term. If we use this in our system, we are able to reduce the net carbon emission. Product recovery, as the name says, the used product or end of life products, they are brought back to value chain. So we should be able to retrieve those products and make something out of it. So that is the product recovery concept. The objective is optimizing resource value, reducing environmental impact and enhancing overall sustainability in a circular economy. The defect management, in my research, product recovery, I'm just using it. Today I'll be talking about defect management. Both are different yet related. So defect management is a technique related to the segregation of defective items into different categories based on the severity of the defect content. For this, an inspection is required that incurs inspection cost, but in the long run, this idea is beneficially, economically, as well as environmentally. In the starting, we are putting some money, we are investing money in inspection cost, but we'll see later on how it is beneficial to us only from the financial perspective and environmental perspective. So what happens post inspection? First inspection is carried out for the defective and good quality. After that, a second inspection is carried out to segregate the defective items into different categories. It is not the case that each defective would be have the same defect level. Some are reworkable, some are recyclable, some are reused. So those second inspections, through that second inspection, we can go for reworking and recycling processes. So this will lead to not only reduce waste emancipation, but also aid in financial growth. Why? Because we are able to sell these derived products again and again in the market. So though we are investing money in reworking, recycling, inspection, but later on we will see if they are fetching us more revenue only. And plus there is an environmental advantage. We are not disposing waste to landfills, it is not being burned, so carbon emissions are being reduced. So in the present study, a model with flexible production rate using renewable energy, investment in green technology and defect management strategies has been proposed to control the amount of greenhouse gas emissions produced during production and disposal. For managers and decision makers, the research offers some crucial ideas on how to manage a production inventory system, taking into account environmental as well as economic sustainability. So when we talk about sustainable production, all these efforts that we are putting in to make our production system sustainable is also being, acknowledged by the customer. Today, the customer is more eco-conscious. So there is a relationship with the demand also. It is not if some customers are prefer to buy organic products. Organic comes under the category of green. So we have seen the demand is influenced by green practices. And obviously, as we put green technology, the price is going to, the overall cost of the product is going to increase. So demand is ruled by price, that is from generation, plus the green technology. So in my research, I have taken both the effects. Obviously, price plays a crucial role with the green efforts. This applicability of green technology we have seen in many industries. The most common Zara, H&M. In H&M, you will observe products under different categories also rewear, reuse and recycle. And also we see some categories organic cotton. So industries are adopting fast these green and sustainable practices. So in my study, I have proposed two approaches, the traditional and sustainable approach. Via traditional approach, we are going to dispose the defectives, whatever defective items are being produced by production process, into the landfill, and when they are burned, they will be responsible for increasing the carbon load in the environment. But via the sustainable approach, we are categorizing the defectives into different categories and reworking and recycling them. So this will, through mathematical framework, mathematical analysis, we have seen that this is going to increase the profit and reduce the carbon load. So just giving just a brief introduction of my study, what is happening here. So we have the manufacturing process, the manufacturing which is considering the investment in green technology. Then after the manufacturing the product, via first inspection is bifurcated into two categories, good quality and bad quality. Good quality goes to the market for the sales, but the defective products are being again go through the second. We have two cases actually for defective, as I told you, two approaches. So in our model, we have compared both the approaches. Case one is the traditional one, but the case two is the one where we are recycling them and reworking them. So this is the basic structure of my study. Now I'll just, the objective, obviously we have different decision variables. As I told you, the price remains a factor. When we are going to invest in green technology, the overall product cost increases. So to optimize the price with my investment in green technology is one of the major challenges that we are going to see. Plus the production rate, since we are considering a flexible production rate, not a static production rate. And the objective is obviously to maximize the profitability. We will also see through different comparative analysis how renewable energy helps aid the smart production system. How does green technology help reduce the effect of carbon emissions? and how the model with defect management is better than the model without with inclusion economically and environmentally. Okay, just the basic cost in the model remains the same. I will not, I just want to tell you the comparative analysis. The basic cost structures remain the production cost, setup cost, holding, inspection, carbon emissions. These we have taken. In the second case, we have taken the reworking and recycling. So I just wish to, since we have less time, to conclude with the comparative analysis that we have done. So we have compared our proposed model with the different cases. Relaxing the assumption like the case one, the model is without the flexible production system, or you can say renewable energy. Here also the profit is less and the total carbon emission cost is higher. You can see the last two rows. We have compared the profit and the carbon emission. So sustainability, the environmental aspect with the total profit, that is the financial advantage. So without renewable energy also the profit is less with higher emissions. Without defect management strategy, that is the traditional approach. Again, the profit is lesser, emissions are higher. Without green technology, the same result. And the last one is the most, you can say the unfavorable case when neither we are incorporating defect management and green technology. The profit is lesser and the carbon emissions are too high. So this is the basic, objective of the study. We offered a mathematical framework to incorporate sustainable strategies into a production system. So every production from industry nowadays, I think they should incorporate this strategy. Why they are hesitant? Because the initial investment in such strategies are higher. But in the long run, we can see by giving new dimensions, we are able to fetch more profit, and plus we are going to, responsible for our environment. So for that purpose, sustainability, incorporating sustainability is not a choice now. I would say it is a must for everyone. So through my research, I just wanted to showcase the profit aspect, because that is the first aspect that industry is going to. And plus with that, in the environmental aspect, we are able to reduce the carbon emissions. So this is the basic study I wish to share with you today. Thank you. I've just concluded it as you said. Otherwise, I have other things. Thank you, sir. Sustainability.
What is the mathematical model? Which is that parameter which speaks of sustainability?
Sir, sustainability in our model, we are talking about with the in regards to carbon emissions. So through every production process and transportation and through disposal, we assume certain emissions are emitted. So we take into that, and the government implements taxes. So through sustainability, the total carbon emission cost is being reduced. That factor, through cost analysis, we are addressing sustainability.
And the other one, the beginning, sustainability.
The financial advantage. Strategic is incorporating strategy. Green technology has incorporated the carbon reduction function. Total carbon emission, they are being reduced by green technology. But in the title, strategic just means we are not doing a simple framework. We are strategizing how to achieve sustainability.
Strategic model.
Yeah.
So what is this strategic model?
Strategic model, as I said, incorporating strategy.
It's the strategy.
Strategy is the green technology investment. That is, we are optimizing how much to invest.
That is incurred?
Yes.
And put it back into the equation?
Yes.
And then something will give you the
optimal value.
Sustainability. You will not
See, well, as I said, sustainability can have different dimensions, but in our model, sustainability I'm addressing with the total carbon emission cost in the model. Through that aspect, I'm addressing sustainability. But as you said, there should be some coefficient. But this is the idea that I've just got after talking to you, how to incorporate.
Equation or the term that
insert in the original equation, which accounts for sustainability strategy.
Yeah. So
This is a strategy.
That is we are adding the cost actually for the for the product we do the only the strategy is not like the production strategy. We are on the original cost. That is otherwise there is no strategy like this for delivery of production is nothing like that. There will be the cost.
If some people say that this is now brought in this name and that name, when you write introduction, the title, and how do we manage? And surely there is a paper on supply chain. As I said, has 18 constraints. Okay. In your case, do you have any constraint?
in this model not, but in other model we have used a constraint on carbon emissions.
Constraints normally
The total carbon in respect to sustainability, the carbon emissions. That
constraints will count.
as a count, by counting we in till now in my research I haven't used much, one or two constraints here. Well, that please send us the paper. I will see and try to study.
It is
Okay. Yeah. Thank you, sir, for your queries. I try to look over that part also. Thank you.
So thank you very much, Dr. Aditi Khanna. She worked on the sustainability environment. And thank you for Kapoor sir for valuable questions and also giving us suggestions to improve our research. Now the next speaker is Professor Deepa Sinha. Deepa Sinha received PhD from Delhi University, India in Applied Mathematics 2007. Earlier, she did MSc in Mathematics from Indian Institute of Technology, Kanpur in 1994. And since then, she has been serving several institutions for graduate and postgraduate courses, particularly Khalsa Girls College, then Delhi College of Engineering, Manasali University, and Delhi Technical University. Her PhD dissertation, A New Frontier in the Theory of Signed Graph under the guidance of Professor Mukti Acharya. She has guided many students in discrete mathematics in MSc, MPhil, and PhD level. She has qualified CSIR NET twice and had been awarded Junior Research Fellowship by MHRD to carry out research towards her PhD in Delhi University. She was also the member of Syllabus Committee in Central University, Rajasthan. She has referred several research papers for national and international journals of high impact factor like Discrete Applied Mathematics, Graph, and Combinatorics, International Journal of Physics, Science, etc. She has more than approximately 110 research papers to her account in journals of high impact factor. She has chaired several sessions in national and international conferences, and she has guided 16 research students. So I'm thankful to her. Sir, ma'am, you are invited for your talk.
Good evening, everybody. My sincere thanks to the organizer for giving me a chance to speak to the student on this auspicious day of National Mathematics Day. And we are paying homage to Ramanujan. And because Ramanujan mostly was working on numbers, and this day mainly we try to motivate youngsters to how, if you go through the life of Ramanujan, it was a very terrible life. He even flunked in high school, but still he managed to get such a position that he had a position in Royal Society of London and whatnot. And everybody who earlier did not recognize his work were giving him award. So if I go through the history of Ramanujan, it will take time. So let me just try to talk in terms of number, taking a very easy example so that the students get motivated, because motivation is also very much necessary to get into the world of to get yourself very name, fame, and anything. Okay. So today I will be talking on encryption and decryption. So encryption and decryption, or you say cryptography, is a field where mostly, you know what, you try to encode certain things which you don't want to pass it generally to the general people, but then to the receiver only. So you want to confide or keep the things confidential between the general masses, but to the recipient must be knowing how to decode that. So that is how we will be. So how do we use graph theory, or how do you keep the confidentiality of the network? Suppose there is a chaos in some place like Jammu or anywhere, and you want to place a corpse with certain idea between or certain message between them. So that network must not be disclosed to the notorious gang. So how would you go along with that? Or the messages have to be concealed, and how do we go? There are several methods. And again, you know, if you go by the general analytical method, so generally people are using elliptical method. And then as Professor Kapoor was talking, that you keep on adding certain things and you keep on improving. But then for lock and key, you know, it is not that only you go by the traditional methods, because traditional methods, half of the as as good you are in making the program, the other person who is going to crack the program, they are also very intelligent people. So if you are going in the same direction, few things they have to work more to crack the program. So if you have alternate way, that will be again good. Sometimes complexity wise, time complexity wise, it may not be that useful, but then it may be very good because you are going by a different in a different manner. So that is what I want to speak, and then I have to take less time also. Okay. So it will involve preliminaries and encryption and decryption through signed calligraph. So you can use any graph, but I will be taking the example of signed calligraph. See, my area is graph theory. So if you go on and I have been working into the characterization, if and only if condition. So lock and key, so that means if you are very well versed with the characterization, I thought that this idea can be always put up with encryption and decryption with certain more work. So that is what I have done over here. So, so first of all, for the this can be, and is it okay to okay? So what is graph? So I think most of them must be knowing the graph. Graph means in the mathematics we have some entities, and entities are connected by some links. Okay, so in computer science they call it as nodes. The entities are called the nodes on which you are going to model. Entities can never be zero, it can never be empty set, because if you have entities, then only you can model. Okay, and then how they are interlinked to each other, those are called the links or communication links in computer science, but in mathematics we generally call it as a lines or edges. Okay, so I will be restricting myself to mathematics, that is low vertices to the entities. These are the vertices. If you are able to see, these 1, 2, 3 are the vertices, and then these are the links. Like one is connected to 2 due to whatever model, but one is not connected to 5 due to that model itself. Okay, so it will depend on the model. Small example. Then okay, so now what is, if you give the weights to the edges? Okay, so if you give the weights to the edges, then that will be called as a sign graph. Earlier was called as a graph. Now we call it as a sign graph, which will be denoted by S. So S is a function where SU is the graph and sigma is the weight function on the edges. And if it receives plus sign, plus weight, plus one weight or plus weight, then it will be denoted by bolded. Otherwise, if it receives minus weight due to sigma, minus one due to sigma, then it will be denoted by dotted line. Okay, because in see graphs like in computer science, what you do, you give the pictorial representation of the flow chart. So flow chart is to make the things easy to represent and easy to understand. So same is the case if we keep on writing the functions everywhere or weights everywhere, it will be too cumbersome. So we'll do it like that, and if there is no edge, so like there is no edge between 2 and 3, so it goes like that only. So next is, so what is now, I said in my earlier this thing that I will be using unitary calligraph for my encryption decryption. So what is unitary calligraph? So unitary calligraph denoted by xn is the graph whose vertex set is the field Zn. Zn everybody knows, integers modulo n. The and un is the unit set. Unit set are the elements which are, if n is suppose 15, then all those elements prime to n, co-prime to n. Okay. So then two vertices A and B will be adjacent if and only if their difference will belong to un. So un is one set, zn, depending on zn, you can always form un. And if the difference between the two elements are in un, then what you do, you draw a line between them, otherwise you don't draw a line. Okay, so this is what is graph. And then unitary calligraph, I have worked so much on this that and then I have extended this into sign graph. So signed calligraph, again denoted by capital SN, will be the underlying graph SNU, that is whatever you got in the unitary calligraph, and then you have to put the signature on the edges. The edges will be signed plus if A or B, A and B both belongs to UN, and if otherwise minus. So the underlying structure will be given by the graph structure and the signature will be given by the second point. Okay, so this is S12, like S11, where the 11 vertices have been taken care of, and UN, and then accordingly, whenever the difference belongs to UN, then there will be a line, otherwise there won't be a line. Okay, so don't think it is required. So examples of addition to me, we will be, so what is, I'm basically using unitary calligraph, so I'm skipping unitary addition. Okay, so there can be more graphs which can be used. So an algorithm for the students is a procedure or formula for solving a problem. So the word derives from the name of the mathematician Muhammad ibn Musa Al-Khwarizmi, who was a part of the royal court in Baghdad and who lived about 780 to 850 BC. In mathematics and computer science, algorithm is a step-to-step procedure for calculations and is used for data processing and automated reasoning. So there can be different ways to store the graphs into the computer, because we will be transferring the network to the computer where we will need to conceal the information. So in computer, the data structure depends on it will depend on the graph structure, whether the graph is sparse or dense. An algorithm used for manipulating the graph. So theoretically, one can distinguish between list and matrix structure. So, but in concrete applications, the best structure is often a combination of both. Sometimes, list of edges are being given, which will give the display of what all vertices are being connected to each other. And sometimes adjacency matrix, if you have learned graph theory, you will know what is adjacency matrix. So adjacency matrix is also defined over here. The adjacency matrix of sign graph S with n vertices will be without any parallel edges will be denoted by capital A is equal to Aij, which will be taking the value where the entries will be taking the value -1, 0 or 1. Like Aij will be 1 if Vi and Vj is a positive edge, means under the signature sigma is receiving the plus sign, and will be -1 if Vi Vj is a negative edge, and will be 0 if Vi Vj is not an edge. So secret communication have been needed by military officers, diplomats, and many others since very long time. In today's advanced age, where the internet, mobile phones, and computer technology are widely used in almost every sphere of life, the need to keep important information secure and confidential is also increasing day by day. So again, I am repeating, it says over time, as data security continues to evolve, new ways to break the confidential communications are being discovered. So new ways, that is why this work which I am presenting is coming up. Okay, new ways, otherwise traditional ways, you go by electrical curve, face recognition and other things. So cryptography is a study of changing restricted information into coded data so that can securely arrive at its end without any spillage. Spillage means without any spill of the message. It was fundamentally used for at the wartime and old style cryptography, and it is being revisited now. So modern cryptography is highly connected with discrete mathematics, and discrete mathematics seep in into every mathematics. Wherever there is no solution, you will see that the discrete mathematics is giving the clue to the solution. Why? Because world is not continuous, it is discrete in nature. Every problem is, if you want to work it out, it will not be continuous, it has a discrete character. So studying this discrete mathematics is equally very, very important. Many cryptographic algorithms are directly used on mathematical results. Cryptography is the scientific and practical activity associated with developing of cryptographic security facilities of information and also with augmentation of the cryptographic resistance. Cryptanalysis is the scientific and practical activity of analysis of cryptographic algorithms with the goal to obtain estimations of the cryptographic resistance. So these are I'm just letting you know because these are the definitions only, okay? Once you come to the example, I think you may also be enjoying that. Cryptology, crypto encryption, encryption means you code and decryption means you decode, okay? And then coding means when you have some data which you have to code, that is called the plain text. And if you have coded, that is called the ciphertext. So encrypted data which is coded is also called the ciphertext in the language of cryptography. So now, so here we will be using unitary sign calligraph along with private or symmetric key to securely encrypt and decrypt the edges of the graph. So what the idea is that the message is transferred through the edges of the network of the graph that is being considered. Okay. So I think let me because I have to I'll just come to directly to the example. So let the graph be plain text or the original message be represented as a sign graph. S is equal to V1 E1 sigma 1. So V1 is the number of vertices which is being taken is equal to N, and E1 is the number of edges according to whatever is the network you are working with. Okay. So E1, E2, EM1 is the number of edges and N1 is the number of vertices. Because we are using what unitary calligraph. So calligraph what was the vertices? Vertices was Zn. Integer modulo n. So the vertices will be labeled as 0, 1, 2 up to n1 minus 1 or n minus 1. And then now based on the number of vertices in the sign graph S, this is the click according whatever network you are taking which has to be transferred. How do you code it? You take another unitary calligraph with the same number of vertices and edges according to the definition. So some of the edges will become double in that case because you are going to superimpose both the graph to each other because the vertices are same. So you keep the graph sign graph and then unitary calligraph sign graph on that. So some of the edges will get doubled and some of them will be single edge only. So means there will be parallel edges generated. Okay. So in the context of encrypting a sign graph S and its associated message, the first stage involves defining a new sign graph S dash based on the pre-existing sign graph S. Specifically, we construct S dash as follows. S dash is equal to V dash E dash sigma dash, where V dash will be same as the vertex of V1 or the vertex which has same vertices of unitary calligraph, and E dash is the set of the edges defined as the sum of the edges, because it will some of the edges will be getting doubled. So it will be and some of them will remain single. So some edges of the sign graph plus the edges of the unitary calligraph. So it may develop a multi-graph. So this is the initial set. This sets the foundation of the subsequent encryption step. That is, it is how you are going to encrypt. So let me take one example. Suppose this is the sign graph you have taken with some of the dotted edge and bold edge, and then same unitary calligraph on the same number of vertices. Coincidentally, it is the same graph. It need not be the same graph. So here it is signed calligraph SN. Next step is that you superimpose each other. So the vertices remain same, but the edges, see, certain the outside edges are from the first graph, and outside edges are from the second graph, and inside edges are from the first graph, as you can see. Okay. So now this is again a very important step. So let me just take the example only. Then how will you? These are the algorithms, okay, and then complexity. So please allow me to complete this example. So because if the students get to know this, maybe some may be interested to work on this. So this is the graph, okay, and then this is the duplicate. This is the sign graph developed due to unitary calligraph. You superimpose each other. Then what you do? You label the word. See, when they are joined, when do they join? When their difference belongs to UN. So that means E1, U1, E1. So now you label the edges E1, E2, E3, E4, E5, E6, E7, E8. So now it has got the double the number of edges. That is sum of the edges of the signed as well as the unitary calligraph, sign graph, sorry. And then you have to develop a function on the vertices, that is tau function, which will be depending on tau 1 and tau 2. And tau 1 is 5wij plus 6 if I belongs to UN or J belongs to, it can be any function. But we are mostly taking the polynomial kind so that it is easy to, because then it will be easy to there will not be a problem of NP complete and all that. Okay, 5wij plus 6, where wij is the weight of the edge, and 2wij minus 1. This will be, the first case will be when I and J both belongs to N, and it will be this otherwise. So, so now see, the weights of, you know what is the weight, plus 1 and minus 1 was already there. So the weights have been due to tau, the weights have been calculated, and now the information will be going as this graph with the new weights. Okay, so this will be the encrypted graph, and then again, because we are using symmetric key for both, just for understanding, you can make it more and more robust by working into the problem or getting into some real life problem. So what happens? You can just take the inverse and then find out. Then you can decrypt also. And then decrypting, you will see that you will get these values of the original, and then you know that what are the edges of the unitary calligraph that can be removed, and then you may get the original sign graph through which the messages was to be transferred. And then the complexity has been worked out at every step. How do you take the complexity? Whatever you are doing, how you evaluate the complexity. So this is what is the complexity. And then mostly, because my area, as I told earlier, that my area is on the characterization. Characterization means if and only if condition. And whenever there is if and only if condition in whichever area of mathematics, you may see, if you have to first work it out mathematically, and you may see that it can have an application in encryption and decryption for sure. Thank you so much. Thank you.
Thank you very much, ma'am. Any questions from audience? Professor? Any questions? Thank you very much, ma'am. Please have a seat. Now I would like to welcome Dr. Rakesh Kumar for online invited talk. This is the second last and we will have one more. Dr. Rakesh Kumar is a full professor of statistics in Department of Mathematics, Statistics and Actuarial Sciences at Namibia University of Science and Technology. Since 2021, he started his teaching career as a lecturer at MIT Business School, MIT University, Noida. Then he moved to Sharda University, Greater Noida, as a senior lecturer, and later on he joined many universities. He obtained his BSc in the year 1998 from Himachal Pradesh University, Shimla. He received his MSc and PhD degrees in statistics from Kurukshetra University during the year 2002 and 2006. He received a gold medal in MSc Statistics for standing first in 2002. He completed 2 mock courses, one on analytics for decision making, Babson College, USA, and the other on Introduction to Operational Research, IIT Madras. He has been awarded the University Research Scholarship for pursuing PhD in Statistics from Kurukshetra University. His main research area is string theory and its application. However, he has expanded his research to include reliability modeling, sampling theory, and hydrological modeling. He has successfully supervised 4 PhD candidates and 16 master's theses. He has also supervised 2 honors students. Presently, he is supervising 4 PhD students, 1 master's student, and 1 honors students at Namibia University of Science and Technology. He is a member of many professional bodies like Operational Research Society of India and many other more. So I would like to invite him for the invited talk. Sir, you can continue.
Thank you, sir, for your nice introduction. Can you hear me, sir?
Yes, I can hear you, sir.
Okay, nice. Let me share my screen.
Yes, it is visible, sir.
Okay. All right, so
you can start, sir. It's visible.
okay, all right. So first of all, I would like to thank Professor Arora for inviting me to this first international symposium on celebrating the contributions of Ramanujan in mathematics at MIT University and providing me chance to showcase my research work. I am also thankful to the organizing committee for running this show very smoothly. Thank you very much. The topic of my presentation is queuing models for cloud computing. My name is Rakesh Kumar and I work at Namibia University of Science and Technology in the Department of Mathematics, Statistics and Actuarial Science. All right, so before moving to the main topic, let me cover some preliminaries. A queuing modeler always talk about or think about a queuing system first. What is the scenario under consideration? Which congestion situation is under our study? So that need to be, conceptualized. So first of all, we consider a queuing system. A queuing system consists of arriving customers from outside, and then if the service is not immediately available and more customers are coming, then they stay in the queue. The second part, and then the service system, which consists of either one server or more than one, and then the customers served. So this simplified diagram represents the queuing system. Now, characteristics of a queuing system. We characterize a queuing system by these things like arrival pattern, how the arrivals occur, is that pattern deterministic or random in nature? Are the arrivals coming one by one or in batches? Similarly, the service pattern, is it deterministic or random in nature? So, are we servicing the customers one by one or in batches? And if it is random, then what are the underlying probability distributions? All right, the number of servers, that's very important. We may have single server queuing systems as well as multi-server queuing systems. Capacity of the system means that how many customers a system can accommodate. Is there any limit? So if there is a limit on the number of customers, then we call them finite capacity queuing systems. Otherwise, we call them infinite capacity queuing systems. Queue discipline, the manner in which the customers are taken for service, like first come first serve basis, last come first serve basis, in random order, service in random order, or some priority queue disciplines. Then, like the car number plate, we have a notation for recognizing the queuing systems A, B, C, D, E given by Kendall. A refers to inter-arrival time distribution, B denotes service time distribution, C number of servers, D capacity of the system, E for queue discipline. So likewise, for example, we have a single server system MM1. Others letters are not written. If these are not written, these are by default. Like this D is not written, it is by default. The capacity is infinite. And if E is not written, it means by default the queue discipline is first come first serve. If these are other than those, we denote that here. So MM1 means Markovian inter-arrival times, Markovian service times. M for Markovian, and exponential distribution possess this Markov property. And similarly, the other one, it is a finite capacity, and the this capital N denotes the capacity of the system. It may be any number like 1, 2, 3, 4, 5, whatever. Similarly here, MG1, so general service time distribution. So this is a non-Markovian queuing model, and similarly C here. So MMC, C servers and finite capacity. So by these notations, we can have the basic idea of what kind of queuing model is this. Yes, now, so queuing modelers wish to study the queuing systems in terms of certain measures of performance, like average number of customers in the system, that is the system size, average number of customers in the queue. So now what is the difference between number of customers in queue and service? So the number of customers in service in the system, that includes the number of customers in queue as well as those in service also. Whereas the number of customers in queue represent only customers waiting for service, not in service. Then average waiting time of a customer in the system as well as average waiting time of a customer in the queue, and then average server utilization. So these are the main measures which one wish to find out. Then before moving to the main research, this is I'm explaining from the point of view of students who may be interested in queuing theory research in mathematics. So so this is very basic model, MM1 single server Markovian model. So a queuing model. This queuing model is based on the assumptions like this. The arrival to the queuing system occur one by one in accordance with Poisson process. And then the inter-arrival times are exponentially distributed with parameter lambda. There is a single server and the service time is exponentially distributed with parameter mu. Capacity of the system is taken as infinite. There is no limit on the number of customers in the system, and queue discipline is first come, first served. So under these assumptions, then we develop the mathematical model. So using the law of total probability, we try to find out the differential difference equations governing this model. For that, we first write this Pn t plus delta t, what is the probability of having n customers at time t plus delta t. So that can be written like this. So n minus 1 at time t and one arrival occurs during time delta t. So that probability of one arrival is lambda delta t plus O delta t. And similarly, this 1 minus lambda plus mu delta t is the probability of no arrival and no departure, and n in the system. So after time delta t, that those also remain like n. And similarly, if there are n plus 1, one departure happens, and then again system goes to n at time t plus delta t. So using this kind of relationship, we rearrange the terms and divide by delta t and take limit delta t tends to 0. We come up with this kind of differential difference equations. This is P0 dash t ddt of P0 t and n dash t ddt of Pnt. Okay. So now these are the right hand side values. This is for n is equal to 0 and for n is equal to 1, 2, so on. Now we wish to solve this system of equations to get the value of Pnt, that is time dependent probability. So we have two kind of solutions, one time dependent and other is time independent, that is steady state solution. So steady state solutions are comparatively easy to find out, however the time dependent solutions are difficult to obtain. Yeah, so one can solve these equations and get the value of Pnt, as well as one can compute the measures of performance. Then the next thing I would like to discuss is Jackson queuing network, because in real life we don't have we have single queues also, but most of the times we have a network of queues. That is, one queue is feeding other, second is feeding some other, and like that. So Jackson network is the very basic network, queuing network, and it possesses product form solution. So yes, what is this? A Jackson network is a system of M service facilities where the facility I from 1 to M has an infinite queue. Customers arriving from outside the system according to a Poisson input process with parameter AI. SI servers with exponential distributed service time distribution with parameter mu I. A customer leaving facility I is routed to next facility J with probability Pij, or departs the system with probability Qi, where Qi is equal to 1 minus this probability, J from 1 to M Pij. Any such network has the following key property. Under steady state conditions, each facility J in the Jackson network behaves as if it were an independent queuing system with arrival rate lambda j is equal to aj plus summation over I from 1 to m lambda I Pij. So this is the overall arrival rate to the particular node, and this is outside arrival rate, and this is the total arrival rate from the other nodes. Now, yes, we can view it like this. Suppose this is node I, then so say gamma is the outside arrival rate and these are the rates from the other networks. Similarly, after receiving service over here, the customer may go out of the network or may go to other nodes with these probabilities. If we consider that there is a single server at each node, then if in an open junction network, this lambda I less than mu I holds for all q's I from 1 to m. The steady state probability of the network can be expressed as the product of the steady state probabilities of the individual q's. So it possesses a product form solution. The nodes of the network can be considered as independent MM1 queues with arrival rate lambda I and service rate mu I. So this way we can find out the joint probability of having K1, K2 or Kn number of customers in the network using this relationship. Now coming to the second part, that is cloud computing. So I would like to relate these two things, that how queuing theory comes into play in the performance analysis of cloud computing systems. So before going ahead, let us try to understand what a cloud is. The cloud refers to servers that are accessed over the internet and the software and databases that run on those servers. Cloud servers are located in data centers all over the world. By using cloud computing, users and companies don't have to manage physical servers themselves or run software applications on their own machines. Rather, they can have a contract with the service providers, that is cloud service providers, and they can demand what kind of service they want according to need basis. Okay, in terms of a diagram, we can see it like this. So this is user device. User is interacting with the cloud via internet, and then this cloud consists of these applications and databases. So servers containing applications and databases. So cloud computing, it is a technology of distributed data processing in which some scalable information resources and capacities are provided as a service to multiple external customers through internet technology. A distributed system is one in which computers located at different places communicate and coordinate their actions only by passing messages. The resources are shared dynamically and services are provided to the customers. The resources are shared dynamically and services are provided to the customers on demand. Thus, the users have to pay only for the duration they utilize the resources. It is the on-demand availability of computer system resources, especially data storage, cloud storage, that most of us are using nowadays, and computing power without direct active management by the user.
Excuse me, sir. Your time is, you just take 5 more minutes to complete your talk.
Okay. All right. So for more information on cloud computing, one can go through various PDF files available on internet, google.com, or books one can consider for reading on this literature. I will not consider this information much on cloud computing now. Let me go directly to connection between with queuing theory. Okay, most current cloud computing infrastructures consist of services that are offered and delivered through a service center, such as a data center, that can be accessed from web browser anywhere in the world. The two most significant components of the cloud computing architecture are the front end and back end. Okay, so front end is the gateway to cloud and consists of software components and interfaces needed to connect to platform using more client applications, whereas back end functions include management of job queue, the servers and their virtual machines, and storage server with their database system. So this is here the queuing theory comes into play and helps to optimize the performance of these cloud service infrastructure systems. Yeah, so let me go ahead and come to this queuing theory. Now coming to the first queuing model, research paper, a queuing theory model for cloud computing. It is published in Journal of Supercomputing, and yeah, so these are the authors. This paper presents a model based on queuing theory to study computer service, quality of service in cloud computing. Cloud platforms are modeled with an open Jackson network that can be used to determine and measure the quality of service guarantees the cloud can offer regarding the response time. Yeah, so the combination of MM1 and MMM queues in sequence was proposed to model the cloud platform. So let us see. Yeah, this is the diagram of the cloud infrastructure that has been considered. So this is entering server, and then the load balancer queue, and then there is another server, processing server, database server, output server, and client server. Okay, so yes, so customers are entering from outside, moving inside that. Customers means the jobs, the whatever, you know, job queries they are demanding. So these are moving throughout this network, and then at the end these are processed. Requests are processed, and then these services are provided to the customers. And there is some analytical portion that I am now not showing here. So they have performed the cost performance analysis of this network. And next is my own model, performance evaluations of cloud computing physical machine with task renaging and task resummation, that is feedback. So in this model, task renaging or dropping occurs when tasks wait in queue longer than its their timeout or execution deadlines. The drop tasks could be resubmitted provided they were not dropped due to security reasons. This paper studies simple MMC and queuing system of cloud computing physical machine with renaging and feedback. The effects of task renaging and task resubmission on queuing delay, probability of task rejection, and probability of immediate service have been studied numerically. This is the diagram of the model we have considered, multi-server system. And then these are the assumptions of the model. These are the difference equations that have been made. And then the model is studied in transient state using MATLAB software and using the OD45 function. And all those characteristics are studied. So here we have compared the two models, MMC and queuing model with renaging and MMC and queuing model with renaging and feedback. And there, and we have studied this with respect to average delay in queue and with time. Okay, so as the time increases, so this average delay increases slowly and becomes constant when the system has reached the steady state. However, we can see in case of feedback, so more and more requests are rejoining the queuing system, and hence the queue size will be more, and then the delay will be more. So which this is depicting over here. Similarly, we have shown the probability of task blocking. So in case of model with feedback, so there is a more traffic, and hence the probability of task blocking is more. So hence it is higher than the model without feedback. And similarly, we can study the probability of task blocking with the arrival rate. So as the arrival rate increases, it shoots very high. And yeah, the second model, modeling and analysis of cloud computing systems using queuing models with correlated arrivals and correlated renaging. So correlated renaging is the newly developed concept, and the first paper is published in 2020 by us, and one PhD thesis is already awarded. So yeah, we have shown the application of this model in cloud computing. Yes. So this paper deals with queuing model for cloud computing framework where arrivals are correlated and their engaging at two consecutive time arcs is also correlated. This paper deals with queuing model for cloud computing framework where the arrivals are correlated and the renaging also correlated. It is well known that arrival of tasks in cloud data stream is correlated in nature. That is, there is a dependence of arrival of tasks at two consecutive time arcs. Further, it has also been studied that renaging of tasks in cloud computing systems is correlated in nature. The time-dependent behavior of the model has been studied. Some important measures like average queue length, average waiting time in the queue are computed. Authors have also performed the comparative analysis with the existing models and noted the significant changes. So this is the queuing model under considerations. These are the assumptions. So this is the assumptions related to arrivals of tasks, and this is the two-state transition probability matrix, which shows the dependence of arrivals at two consecutive time marks or transition marks. Similarly, yeah, we have another assumption regarding server. One server service type assumption regarding service type distribution is exponential in nature. Capacity is taken as finite, and then yeah. So similarly, these are the different notations, the probabilities we have defined. This is the model. Yeah, large number of equations. We cannot understand them very quickly. This is the performance measure. These are the performance measures, and these are the results. Okay, and these are the references. Thank you very much. I hope I could finish within time. Sir, you are muted. I cannot hear you. Oh. Maybe you are unmuted, but sound is not coming to me.
ये मना कर रहा है.
Yes, now you are audible.
Okay, now I'm. So thank you very much for your valuable talk. So now we are going for the next speaker, and he joined. Dr. Satyavir, can you hear me?
Yes, I can hear you.
Okay. So thank you very much for joining, Dr. Satyavir. Dr. Satyavir is currently working as a research associate fellow in Institute for Applied and Computational Mathematics at RWTH Aachen University, Germany. Prior to this position, he worked as a research fellow in Nanyang Technology University, Singapore. He completed his PhD in School of Mechanical and Aerospace Engineering from Donggye's National University, South Korea. He also obtained his MTech in Department of Mathematics from IIT Madras. Dr. Singh has a vast research area including computational fluid dynamics, high order numerical methods, hydrodynamic instability, gas kinetic theory, heat and mass transfer, and computational biology. He qualified CSIR NET JRF exam with AIR ranking 38. He has published more than 40 research articles in reputed journals. He has also attended many international conferences and presented his research work in USA, UK, Italy, South Korea, Singapore, Germany, China, Japan, and India. So I would like to invite you to present your talk, sir. And
thank you.
We are running short of time, so if possible, kindly conclude within 15 minutes. I'm sorry for that.
Oh, it's very less time. Anyway, thank you so much for this kind invitation.
Thank you.
So okay, fine. So my screen is visible and voice audible?
It's visible, sir.
Yeah, okay, thank you so much. Okay, I belong to, yes, I'm working in Aachen in Germany. It's a very beautiful city in Europe. And if you have some time, you can visit. It's really amazing city. So regarding my presentation, this is my talk on mathematical modeling and simulation for soaked hydrodynamic instability. Okay, this is the outline, fundamental of hydrodynamic stability. Then I will go for motivation, mathematical modeling, numerical method, then discussion, and concluding remarks. Because I am working in fluid dynamics, so most of my talk in completely fluid mechanics stuff. So I hope you will enjoy. So what is hydrodynamic stability? It means this type of research tells that flow is stable or unstable. If yes, then how the instability is developed actually. You can see in these two images, this is stable and this is unstable flow. In fluid mechanics, we have three types of instability like Rayleigh-Taylor, Kelvin-Helmholtz, and Rayleigh-Mascom instability. I will talk one by one, step by step. In the Rayleigh instability, what happened? We have two fluids of different density, and when the lighter fluids perceive the heavier fluid, we will get Rayleigh-Taylor instability. Like for this one, we have this heavy fluid and this light fluid is perturbed inside, and we are getting a lot of instability actually. It has a lot of application. I will not go more deep here. The second is Kelvin-Helmholtz instability. What's that? This instability occurs at the interface of two fluids layer with different velocity, and it characterizes a lot of formulation of vortexes and wave-like structure like here. So you can this is the Kelvin-Helmholtz instability. Third one, the Rayleigh-Mascom instability is very applicable actually. So what happened? We have two fluids of different density, and we are giving some shock wave. Then we are getting the Rayleigh-Mascom instability. Example for that one, we have some interface with different density, and we have some shock wave interacting, and we are getting a lot of vertices on the interface. That is called Rayleigh-Mascom instability. Okay, so what is the? I am putting the name actually Rayleigh-Mascom instability like a soaked hydrodynamic stability. It gives a lot of complex waves and pattern formation. Main important thing is a Pettigrew vorticity actually. It is a misalignment between density and pressure gradient and dominance. And this has some story behind that anyway. So what is my motivation? I want to model this type of instability and give some numerical simulation. So for that purpose, I am taking some soaked gas bubble problems. This is a very basic configuration. For that purpose, we are taking like a multi-component flow-based physical conservation law. I will describe a little bit after that. Then we develop some numerical method, and then we test so many test cases for validation cases. And lastly, I'm taking I'm discussing this type of instability at light triangle interface. You can see after that, yes. So how can we model actually? This is the conservation law for this is compressible multi-phases flow. This is conservation law for modeling this type of flow problems. This is U is a conservative vector. Here inverse flux. This is viscous flux. I don't know you will understood this part. I don't know, but this was completely like physics and lot of fluid dynamics stuffs. If you are interested, you can see this paper and he described this notation everything here. Let's go. There's some more notations and some physical quantities here we describe in this one. So now we have this mathematical model, and how can we solve actually? So for that purpose, we are giving some lot of numerical methods applicable here. So one of them like find difference method, find volume, find element, and spectral method. And I am working in higher order spectral method. This method is very challenging, is very applicable in acoustic and turbulent flow problems generally. Okay, so if we have, like suppose we have three different methods, find difference, find volume, and find element method. Every method has some advantage, disadvantages. For example, in find difference method is very easy to implement. It can be made high order, but disadvantage is that it's applicable only for structured mass, like uniform mass. So it has some disadvantage. Let's go for find volume method. It's very nature conservative. It's applicable any type of structure, any type of masses. But advantage is to make a high order scheme actually. In case of find element method, it can be any order of accuracy, applicable for any type of masses. But advantage is that it is not naturally conservative, like for soap waves. So I am working in DC method, discrete gradient method. It taking both of approaches, find volume and find element method. It have both of features. For example, like here, it can be high order. It can be applicable for any type of masses here, and it's stable for conservative law. You can see this image actually. So how can it works actually? We have this conservation law. So for handling the second order term, higher order terms, I'm adding some more some additional variable like theta, and we can rewrite this equation as a coupled system of conservation law. Now I'm solving I'm solving this equation. So how can we do that? At first, we need to divide the computation domain like a rectangular element in my case. Then we are defining some element spaces over the degree of L, and this unknown variable u and theta we are writing, we are approximating by the polynomial degree L in this form actually. And here this phi is the basis function. So in this work we are taking orthogonal scale legendary basis function for example this one. Let's go to find element method. What is doing actually? So in that case we need to make a weak formulation. How can we do that? We have this conservation law, this one, and we are multiplying some test function like phi and integrating over the element ek and performing an integration by parts. So we will get this weak formulation. Here this is called volume integral and this is surface integral. Okay. After that, because in this method we have lot of discontinuity element, so we are replacing by numerical fluxes here, like hk and h inverse and this part, and we will write this equation in that form. And here in this my study, I am using the Riemann solver LC for inverse flux and for alternative scheme for viscous and auxiliary variables. After that, what will be happening? After combining all the mathematical formulation, here we are getting semi-discrete system of ODE in something that now we want to solve. How can we solve? We are using some time integration scheme. For example, explicit third order Rengakuta scheme, something like that. And here delta t is the time step. We are calculating by this mathematical formula. And here we have CFL. CFL is count Frederick's Ravel number. Okay, so this is a little bit summary of this numerical method that I applied here, and you can see some more detail in these two papers that published last year and this year also. Let's go for resultant discussion part. So at first we have two component software problem. It's very fundamental problem in aerospace engineering, mechanical engineering stuff. We have some discontinuity at x is equal to 0.5 and something we will get something like that. When we are solving this problem in 1D problem, we will get something like this type of profile actually. And here the dot symbol is the exact solution, analytical solution, and that the dot symbol is numerical, and that red symbol, red line is the exact solution actually. You can see it's very promising result here about the numerical method. After that, let's go for some more validation case. So in this case, we're taking 2D soaked light cylindrical bubble actually. So we have some bubble filled with some gas like light gas bubble like helium. We put in some shock wave and that bubble is deforming actually. In the first row, we have some experimental result. The second one, they publish one computational result. In the third one, in the second row, and third row, I have my numerical result. You can see the comparison here. And it's matching very good actually. And this published in the Physics of Fluid in 2 years back. And after that, we have for more validation purpose, what we did here, we are capturing that soak trajectory points like downstream interface and jet and upstream here, and we are matching with the experimental result here, and it's matching perfectly. And second example, we took the square bubble actually, like it's filled with some helium gas, same thing. We put in some shock wave here and see the bubble, how is the bubble deforming. So if you see here, if we have a cylindrical bubble and we have a little bit different bubble, like different initial interface, that bubble deformation completely different here. And we are matched with the experimental result that published in this year. And after that, we measure the height and the width of that interface, and we match with the experimental result, and it's matching very. Let's take one example here. If we have like triangle type bubble, like some interface, like for this example, this is my script diagram here. We put in some shock wave here, and bubble is filled with a helium gas. We have we've taken 3 types of gases like argon, nitrogen, and atomic gases in the ambient. And my shock wave number is 1.21. These are some pressure values here. And for shock wave values, we are calculating by the scheme actually. Let's see that's whole flow morphology of how some interface is deforming actually. This is my initial bubble, this is my shock wave here, and we are putting here. Then you are seeing lot of wave patterns actually, different complex wave pattern, and how this bubble is deforming and how they are making a lot of vertices on the interfaces. And if you see here, we are taking 3 types of different gases actually, argon, nitrogen, and methane gas. You see here the bubble deformation completely different here. So something, a lot of physics behind that. I'm not discussing more here. Let's see like time evolution of 3 types of interfaces in 3 different gases actually, and that deformation and making the instability on the interface is completely different. So it depends how you are putting the gas actually in the ambient. Lastly, how making the vertex is on the interface. That is called a parallel vorticity actually. When you putting some shock wave, we are getting a lot of baroclinic vorticity. What is this type of vorticity is actually this is misalignment between the density and pressure gradient. In case of shock wave, we have the pressure gradient. In the case of bubble, we have a density gradient. When they are misalignment, we are getting lot of eddies on the interface actually. That is called vorticity. That is baroclinic vorticity.
2 minutes more, please.
Okay, no problem, sir. This is going to finish now. So these are vortex generation comparison with 3 different gases, and of course here, how that this negative, the blue one is like a negative vorticity, and this red one is a positive vorticity, and how they're making the difference here. This is my concluding remarks. So in this, we are giving some mathematical modeling for some hydrodynamic stability in like determined mass instability. And for this purpose, we developed some numerical method like DG additional calculation method for numerical simulation. We tested several test cases for validation purpose, and we checked how the instability is evolved as a light triangular bubble. And this type of work is now in progress in my research on daily life application basis. And this is like some selected publication last few years. And thank you so much. This is my talk actually. I can't give all the things within 50 minutes. Sorry for that. Thank you so much, sir.
Thank you very much, sir, for your valuable talk. If any questions, any from the student side or faculty side? So, Dr. Satyaveer, thank you very much, sir, for joining us. And
Thank you so much, sir.
I would like to ask Professor Arora to continue the session. So we will start the concluding ceremony soon.
I request Professor Deepa, Professor Mandeep, Aditi ma'am, Arora sir, Divya ma'am, Subhi ma'am to please come up on the dais.
So I hope you found the session both enlightening and engaging. Thank you, sir, and thank you to all the speakers once again. On behalf of everyone present here, I extend our deepest gratitude for gracing us with your presence, time, and wisdom. Your contributions have been instrumental in making this event a resounding success. I would now like to request Dr. Surbhi Gupta ma'am to honor Professor Aditi Khanna ma'am with a memento. Next, I would like to request Professor Divya Agrawal ma'am to honor Professor Deepa Sinha ma'am with a memento. Next, I would like to request Professor H.D. Arora sir to honor us by presenting a memento of Professor Mandeep Mittal sir. And now I request Dr. Priyanka ma'am to proceed for the valedictory session.
Good evening, one and all. We extend a warm welcome to each one of you to the valedictory session of the first International Symposium on celebrating contributions of Ramanujan in mathematics. The day has been marked by captivating talks, insightful deliberations, and engaging discussions on diverse research topics presented by esteemed mathematicians specializing in various fields of mathematical sciences. Now, with great pleasure, I would like to invite Professor H.D. Arora, sir, Head of the Department of Mathematics at Amity Institute of Applied Sciences and the convener of ISCC-RM 2023, to present the symposium report.
Good evening, everyone. This ceremony marks the end of a truly enlightening experience at the International Symposium celebrating the contribution of Ramanujan in mathematics on the special occasion of National Mathematics Day. Today, we have had the pleasure of exploring various facets of mathematics with experts from around the world. Firstly, I wish to convey my deepest appreciation to our visionary founder president, Sir Dr. Ashok Kumar Chauhan, for establishing this esteemed institution, for giving us a platform to organize this symposium in our campus. I extend heartfelt thanks to our esteemed Vice Chancellor, Ma'am, Professor Bandha Shukla, Ma'am, for gracing us with her presence, for her constant support, motivation, and blessings. My sincere thanks to our Head of Institution, Professor Smita Ratan, Ma'am, for her constant help and guidance. We were honored today by the presence of Professor Sushil Kumar Khatri, sir, Dean, Research, Innovation and Extension Activities Outcome, and Deputy Director General, Amity Foundation for Science, Technology and Innovation Alliances, Amity University, Uttar Pradesh. Professor Mandeep Mittal, sir, School of Computer Science and Engineering, Computer Science, Engineering and Technology, Banath University, Great Noida, as our session chairs, who helped steer today's activities with fins and assured a seamless flow of knowledge and ideas. We are grateful for the presence of the esteemed personalities, Professor Sushil Kumar Tomar, Vice Chancellor, J.C. Bose University of Science and Technology, YMCA, Faridabad, Haryana, as our chief guest, and Professor Om Prakash Yadav, Professor and Chair, Department of Industrial and System Engineering, North Carolina, Agricultural and Technical State University, USA. Ms. Mani Agrawal, Under Secretary, Development Partnership Administration, Minister of External Affairs, New Delhi, as a guest of honor. Today's progressions include various keynote sessions in diverse topics, ranging from software testing to shock hydrodynamics instability, which enriched our understanding of mathematics. We had with us Professor Om Prakash Yadav, sir, who delivered an insightful keynote on roles of mathematics in building reliability productive, proactive approach of design. Professor Santosh Kumar, School of Science, University of Melbourne, Australia, shared his expertise on creation and use of alternatives in solving some combinatorial network hard optimization problems. Professor Mohammad Tamsir, Department of Mathematics, Jazan University, Jazan, Saudi Arabia, enlightened us on reconstruction of a potential coefficient in Rayleigh equation with non-classical boundary conditions. Professor D.S. Huda, Honorary Professor of Mathematics from GJ University of Science and Technology, Hisar, delved in Srinivasa Ramanujan, his life and contributions. Professor P.K. Kapoor, Director, Amity Center for Interdisciplinary Research, Amity University, Noida, provided insights on software testing and product adoption. Dr. Aditi Khanna, Department of Operational Research, University of Delhi, discussed strategic modeling for sustainable production inventory systems. Professor Deepa Sinha, ma'am, South Asian University, Rajpur Road, Maidangari, New Delhi, presented an on encryption and decryption scheme to signed telegraph. Professor Rakesh Kumar from Namibia shared expertise on queuing models for cloud computing. And lastly, Dr. Satyavir Singh from Germany contributed insights on mathematical modeling and simulation for shocked hydrodynamic instability. I would like to conclude by saying that let us all carry the spirit of this symposium forward, fostering collaboration, innovation, and a deep appreciation for the contribution of Ramanujan. I want to express my sincere appreciation to our esteemed delegates. Your continued participation will undoubtedly enhance the value of our future gatherings, lecture series, workshops, and conferences. Thank you.
Thank you, sir. In conjunction with ISCCRM 2023, the Inspire Club of Mathematics AIES hosted a Ramanujan themed quiz competition on December 21, 2023. The event was conducted by the faculty coordinators Dr. Jayanti Pandey ma'am, Dr. Astha Malhotra, and Dr. Abhinav Srivastav. Now I would like to invite on stage Dr. Jayanti Pandey ma'am to reveal the winner's name as well as to announce the awards for poster presentation.
Thank you so much, Priyanka ma'am. A very good evening to everyone present here. As the quiz competition is for the celebration of Ramanujanji's birthday, so we have tried to indulge children in their logical reasoning, their mental ability, plus the history and the life of Ramanujanji, so that children know what kind of mathematicians our country has produced so far. So we had a very good quiz competition, and the winner is Ashish Moore from BSc 6th semester. I request our HOD sir to come and present the certificate and memento.
I request Jayanti ma'am to felicitate them.
Yes, Ashish, please come. Thank you so much, sir. Second prize is shared by 3 students. Tamanna from BSc 4th semester, 6th semester, Steve from 4th semester, and Prateek from B Statistics. I request our ex-HOD, Mandeep sir, to present the certificate and memento. And today we had poster competition also. So there were 29 posters. Out of 29, 9 were online posters and remaining 20 were offline posters. So that include our UG, PG and PhD students. So the first prize goes to Miss Anila B. Pillai, Department of Mathematics, Wells Institute of Science, Technology and Advanced Studies, Chennai, Tamil Nadu. She is an online candidate, so her name is only announced. Her certificate will be posted later on. And the second prize goes to Mr. Anil Kumar Yadav. This was an offline presentation. Congratulations to Anil. And Rupakshi ma'am's student. Congratulations, Anil, and all the best. And the third prize
For the third position goes to Ms. Simranjeet Kaur. I request Simranjeet to come on stage. So with this announcement, I post a competition announcement are over. Thank you so very much. And I'm handing it over to Priyanka ma'am.
Thank you so much, ma'am. Thank you, sir. May I now request Dr. Divya Agarwal, ma'am, organizer of ISCCRM 2023, to propose the vote of thanks.
Thank you, Priyanka. Respected professors, esteemed guests, and fellow participants, on behalf of the organizing team, I extend profound gratitude and offer a sincere vote of thanks. Firstly, I wish to convey my deepest appreciation to our visionary founder president, Dr. Ashok K. Chauhan sir, for establishing this esteemed institution. His foresight has provided us with a platform of organizing enriching events with our academic community. This international symposium would not have been possible without the constant support and guidance from our Chancellor Sir, Dr. Atul Chauhan Sir. Thank you, sir. I extend heartfelt thanks to esteemed Vice Chancellor Ma'am, Dr. Balwinder Shukla Ma'am. We are grateful for her encouragement and support in organizing such events. Furthermore, I express sincere thanks to the head of the institution AIS, Professor Sunita Ratan Ma'am. Her visionary leadership and unwavering commitment to academic excellence have played a pivotal role in shaping AIS into a distinguished center of learning and innovation. I also acknowledge and express my deep gratitude to the head of the Department of Mathematics, Professor H.D. Arora. His dedication and leadership in the mathematics department has been instrumental in fostering academic excellence and nurturing the next generation of scholars and innovators. We deeply appreciate his support and commitment in creating enriching educational environment. I also thank Professor Seema Garg, Professor Sangeeta Tiwari ma'am, Professor R.S. Pandey, Professor Dheeraj Pawar, Professor Christine, and Professor Ashok for their constant support and guidance. Additionally, I extend my gratitude to my colleagues and non-teaching staff whose invaluable support and assistance have been crucial in making this symposium informative. Also, I would like to thank IT team, admin, and the support from the media for this symposium. A special thanks to all the guest speakers who have joined us today. Your expertise and diverse perspective undoubtedly added immense value to this symposium. The knowledge exchange and insightful discussions would definitely prove to be transformation for all of us. The active participation of everyone involved made this event a resounding success. Let's carry forward the knowledge gained and continue to collaborate for future endeavors. Thank you. Thank you so much for support.
Thank you so much, ma'am. As we draw the curtains on this remarkable valedictory session, let us carry with us the inspiration and knowledge shared today. We extend our heartfelt gratitude to all the dignitaries, speakers, and each one of you for being the part of this memorable event. May the insights gained today continue to ignite our passion for learning and innovation. Wishing you all the very success and fulfillment in your endeavors. Thank you.